Hello, wonderful people of the internet. Welcome back to another episode of Simuleos Gibbous, and anyone who might be lurking in chat, hey, thanks for being here. So, a couple things to note. We are going to be doing the workout every hour on the hour today for a number of reasons. The first reason is that I was walking fairly normally today, and so I think I can do it again without too much trouble. And the other reason being that today should be a little bit longer of a stream, 3 hours, so it's not that much longer, but it's longer enough that I feel like we can start to do some extra things in addition to the stuff that we would normally do. But yeah, so I think it should say that we have, oh, sorry about that. I need to change to the appropriate scene. But now it should say that we have, should be leg lifts coming up. Let me check to make sure. Yeah, 105 leg lifts. So that's coming up. Hey, Amaris, how are you? So yeah, that's the plan. Again, you guys can use your channel points for whatever you want. I'll try to keep track of it. We can increase the difficulty of the next set, decrease the difficulty of the next set, shuffle all exercises, and add push-ups. And these are the things that you guys can do. Increase difficulty. Sure, go ahead. Over here, set increase difficulty. Perfect. Anyway, so we're good to go. Push-up. Gonna go ahead and add a push-up in there. I think that was right. I may have forgot my keybinds. So let me double check to make sure that actually worked. Yes, it did. Perfect. So again, you guys can add up to 20 push-ups throughout the hour. I think it should be one push-up every 3 minutes is allowed. Otherwise, I might have screwed up when I re-enabled everything. Anyway, let's go ahead and talk about what we're doing today. The next workout will be on the hour. So we have about 59 minutes and, well, 58 minutes and some amount of seconds before we will start to do the next exercise. So 0 PP. Move this over there, move that over there. By the way, guys, I do apologize. The last 2 streams, I've just been like, I don't know, maybe it's because I have not been streaming like regularly or whatever, but I just have not been able to string together sentences to save my life. Like, the words that were coming out of my today's going to be another day. But the words that were coming out of my mouth were like, they were words, but they did not like cohesively form sentences, if that makes sense. I don't know what was going on. In fact, I still think I'm under this weird like inability to make proper sentences phase of my life. But hopefully that will be solved in the next few days, especially now that I'm starting to be more physically active and all this kind of stuff. I will be getting my next vaccine, my final shot actually, on May 11th, which is about 5 days from now, so next Tuesday, and so I may or may not be streaming on Tuesday and Wednesday, depending on how bad that makes me feel, but that is, the only thing that's really coming up in the immediate future, besides the fact that in May, the end of May, I will be traveling back to Alabama, and then I'll be traveling to Japan, and I probably will not be streaming the first, maybe second week in June, or something like that. Okay, so let's talk about what we're talking about today. Barnsley, Fern, give me a second. Okay, so we have been talking a lot about fractals, and in particular, iterated function systems. The way iterated function systems work are essentially, you have a set of functions, and you iterate through the set of functions. It doesn't matter how you do it. The point is that each function will move a point in space somewhere, and you kind of go through and just choose one function at a time. I'm going to get my first shot on May 16th. Super exciting. Like, honestly, I think everyone kind of feels this way, but getting, your first vaccine shot is just like, it doesn't change anything. Like, everyone knows it doesn't change anything. Like, you're still going to have to wear a mask going outside. You're still going to have to, there's so many things you're still going to have to do. But on the other hand, getting the vaccine is kind of like one way of just saying, like, finally we can put 2020 behind us. And it's 2021. It's May 20. We're almost halfway through 2021. Just for the record, in case anybody's keeping track, we're almost halfway through this year. And we are still dealing with COVID-19. 2019. That's a year and a half ago, So apologize or unfollow. You didn't see the notification. I had to apologize in the notification. Let me get an autism booster. Look, my point is the following. I just feel like there's something to be said about just trying to shut the door, with everyone else collectively as a society, all trying to shut the door on this year, this past 2-year session. And yeah, that's, I feel like there's something to be said about everyone together just saying, like, look, this is what we need to do. Now, admittedly, 30% of 30% of U.S. citizens are apparently not going to take the vaccine when it comes out. I added the push-up and also increased the difficulty of the next set. But hey, like, you take what victories you can. At least in Japan, my girlfriend's not able to take the vaccine until October, so it's, I don't know, like, we're very lucky and privileged to be in the United States where we're able to get the vaccine so quickly, especially when, certain countries, like India, for example, are really struggling with it right now. So, I don't know. It's just stuff to kind of keep in mind. Shuffle all exercises. Okay, sounds good. What do we have here? I think if I do set and then we do shuffle, I think that'll work. Unable to... okay, so we have been getting... okay, let me see what the set is. Did we just shuffle into... no, we didn't. Did what? Legless rollout, good morning. Legless bicycle. Shuffle gave us the exact exercise that we... Shuffle gave us the exact exercise that we had beforehand. Let me just make sure. Because clearly... let me just run superset. Okay, so here's what we have. Chair pose, double unders, push-ups, legless. Up here, legless. Yeah, it definitely... I'll shuffle one more time. Because that's kind of not fair, is it? Okay, this is calf raises, and we have to increase the difficulty twice, I believe. So let me go ahead and do that. Set, increase difficulty. No method matching set. Set. Okay, well, let's add a push-up then. And let's just say set is going to be equal to this guy. And now we can increase the difficulty and increase the difficulty again. So how many calf raises is that now? We're at like 165, I think. Oh, no, we're above that. We're probably at 200 calf raises now. I have no idea. 220 calf raises. Okay, perfect. We're going to have some really, like, solid calves by the end of this. Cool. Okay, so let's just keep going. And talk about what we're doing with the Barnsley Fern in particular. So, now, like I said before, the iterative function system is a combination of a bunch of different functions, and there is a particular set of functions that creates the Barnsley Fern. I added the push-up CVC. So, what we want to do is kind of figure out exactly how those functions work. And so I'm kind of going through, working with the visualization that we have and trying to make it more intuitive for people who are just trying to figure out how exactly this particular function system makes the visualization that we're looking for. So that's where we're at. And for those of you guys who may be wondering, let me go ahead and open up Barnsley Fern Wikipedia. Here we are. And let's take a look at the function system. So this is a set of functions. Let me make it a bit bigger. That's smaller, bigger. Here we are. So this is a set of functions. Those who've been watching for a while will know that these are all affine transformations. Each affine transformation is essentially just, you can think of it as a movement in space, some sort of scaling or shearing or movement operator. So the question is, what do each of these guys do? The first one, if you notice, just has 0.16 in here, and literally all this does is, force everything to be at like a stem. So it forces everything to be in like this region in here in space. Then you have a bunch of other operators that do slightly different things. And so we already did the visuals of what each operator does. And so the question is now, how do we show that all these operators put together create the Fern? So I'll go ahead and show what we have now. So let's go here, CD Projects, Simuleos, and Fractal. Same thing over here, CD Projects, Simuleos, and Fractal. Also, guys, I did mess around a little bit with my microphone settings because yesterday, basically what I do is I add an expander to my microphone, which basically, I don't know why it's called an expander, but what it does is it essentially says that any frequencies that are too low, it doesn't register, right? And the reason I do that is to make sure that background noise, ambient background noise, like or maybe people outside, you just can't hear them, right? Like that's the point, just to get rid of those voices and stuff. Now the issue was that for some reason, when I had to redo my audio settings the other day, the issue was that it was like dropping down my it was dropping down, like when I started like breathing in, I was like or something like that, it would for some reason like catch that on the hill, and it would make this weird clipping noise. So anyway, let me go ahead and catch up on chat here. So apologize or unfollow. Like, look, I say it's unapologetic, but you know that my only personality trait is that I am endlessly apologetic. So, you know, it's kind of a joke. Is that because you have a very high-pitched voice? I don't know if that's a compliment or an insult. I guess that's an insult. I apologize for my voice. I know it's not the best voice in the world, but, you know, it is what it is. And, yeah, sorry if it's irritating, I guess. Anyway, let's go ahead and show the visuals. So let's go here and ls. And let's just do mpv barnsley 0.mp4. Okay, so this is a set of functions that we have. The first function basically takes a random distribution of points and creates a line from it like this. Then the next one will do that. And so this one will basically move all the points up and a little bit to the right. This you could imagine is creating like successive sets of these as you go higher and higher up. Then we have two others that I'm not as positive about as to what they do. One kind of shifts and rotates a bit. And then the last function does the following. So it kind of flips around. So you can kind of imagine what these guys are doing, but it's not exactly obvious. And it's not exactly obvious how when you put all these guys together, you get this. You know, how do combining those functions together give you this fern that is clearly like, I don't know. What about increasing the difficulty twice? I think you forgot that. I think I did. Set. The difficulty right now is 7. But actually, I think Gibbous increased the difficulty, and then you also increased the difficulty. Did Gibbous... Yeah, Gibbous increased twice, so we have to increase it one more time. Yeah, so we should be increasing 3 times. So the difficulty is now at 8. So I just had to dig in there. It's not high enough to be irritating. Just had it. I don't think having a high voice is particularly bad. If I'm being honest, I am changing this. I'm not going to use that song. I just don't want to hear that song right now. But I don't know. I don't have a problem with my voice. I think my voice is fine. I suppose, like, you know, I actually kind of like my voice because it's like, it's clearly masculine, but it's like kind of borderline androgynous in some ways. And so like I can kind of get some vocal ranges that are like a bit higher than most guys can, which I think is quite high. I don't know. I kind of like that. But also like, I actually can't do low voices. Like I do try, like actually in some of my older videos, I was always like very self-conscious about my voice, like incredibly self-conscious about my voice. So I would always try to like lower my voice a bit when I was doing presentations and stuff to make it so like, it would seem a bit more like, I don't know, like a bit more like a typical masculine voice, but you know, screw it. Did CVC also increase? Oh, okay. Yep. Sorry about that. I missed that. Thanks for keeping me honest. So we're going to have a lot of calf raises. They did at the same time. Yeah. I think I just missed one of them. So, okay. So now I think we've got all of them. I'm sorry about that. Again, if I missed something, I'm basically just like looking at the side screen. And so if I see an increase in difficulty, I'll add an increase in difficulty. You guys should, for the record, also be able to decrease difficulty if you wanted to. Yep, adding another push-up. Thanks for that. I think I gave you guys that. Yeah, decrease difficulty if you want. But I guess everyone just wants to increase it. That's fine. We'll do 300 calf raises if you guys want. Well, because some people are also doing this at home with me, you know, not everybody, but some people do. Foldster, for example, does. And so if you're doing it at home with me, 300 calf raises kind of is a bit rough. You know, I do find it funny that decrease is the same price as increase. See, I'm not saying you have to. Like, also, it's fine for me. It's just, it means that we end up doing a bit more workout and a bit less coding on like for 15 minutes. Thanks for the decrease. What are we doing here? What do we have? What just happened? So we had push up, decrease, increase, decrease, increase, decrease, increase, decrease. Okay, increase. Okay, I should put a limit on how many times people are able to do this, because honestly, guys, don't spend all your channel points on this. Decrease, increase. What are we at? Decrease. Decrease. Okay, we're at increase. Okay. decrease. Hey, learning balance, how are you? We even when I redeem. Wait a minute. Wait. Where are we? Like on increases and decreases. I don't know. Just re-increase and wait for the battle to finish. Yeah, I'm gonna re-increase, and then someone's just gonna have to tell me like what the end score was. All right, we're gonna get back to the Barnsley Fern. And then we'll see how this... Guys, also, I was thinking about doing other things with channel points, so I do feel kind of bad if you guys just waste all your channel points on this. Because, like, presumably in the future, we'll have other things to spend channel points on. I'm just not quite sure what those guys are going to look like yet. So, yeah, letting you guys know that. I'm trying to find better ways to spend channel points in the future. Okay. So while that war is going on, let's go ahead and just open up. Actually, I'm going to have something playing in the upper right-hand corner or left-hand corner so people can see what we're doing. Project Simuleos Fractal. And now I'm just going to do MPV. What am I doing? MPV Barnsley.mp4. Oh, and we want to loop that. Loop 0. All right, so we're going to have that playing in the upper corner. Here we go. Move this down. It's like the smallest terminal like I think I've ever had on the channel, but that's okay. I have 40K, so I guess we'll call it there. So there was one decrease after all of that. That's good. Thanks. Appreciate that. Okay. But also, like, for rewards for channel points, let me know what you guys are, like, interested in. Thanks, Amaris. I think I just did. So let me know what you guys are interested in. I have been considering doing more like maybe like community polls or whatever it is. You know, like you can do like a what is it? Like you can do like bets and stuff like that. Like you can say, hey, who's gonna win the increase-decrease difficulty war, and like you can bet like a certain amount of channel points for that. And so there's certain things that I could do. Like will I actually complete this in the next hour type of thing. So there's definitely little things that we could do with channel points like that. I agree with Amaris. Yes, I decreased it by 1. So we are now at 250 cap prices, which is still fine. Okay, so now let me go into vi barnsley.cpp. One second. .cpp. Okay, so as of the end of the last stream, I started creating this function that was called the Barnsley twiddle function. Now, what does this do? Let me just go ahead and go to the algorithm archive really quick. Here we are. And let me go to the affine transformation section in here. Okay. So if you look at the affine transformation video, or set of videos, let's just play this one, for example. We basically have a cube or a square that's moving around in space. And you can see how it's moving around because we have essentially the set of like the transform that's happening, which again, all these transforms are very similar to the transforms that are happening with the Barnsley Fern. And then we have this kind of dial that's moving back and forth. And we have the equation changing in the upper left-hand corner. So I was thinking about doing the same visualization except for the Barnsley Fern and like rebuilding the Barnsley Fern, just kind of running it again and again and again and again with a new set of parameters. The advantage to this is that this is actually going to be a really difficult visual to make, so I'd have to spend like all day Saturday making it, but we want to see like what it looks like in the end to see if it's actually worth making the visual for it. Because honestly, it's going to be a pain if I have to make this visual again, but we already have all the elements, so maybe we just go for it. Anyway. So this is kind of the visual I'm trying to make. Something that's like this, like some sort of equation that's changing with time. What do we have here? By the way, thank you guys for the war, I guess. I have 40K, so I guess we'll call it there. Gibbs won. I finally have more points than Gibbous. You're welcome. All right, let me get some water. Cool. Okay. So what I'm going to start with for this function is I think I'm just going to try to draw just a fern with a certain set of functions, and then I'm just going to essentially say, we're going to twiddle this function back and forth, this parameter of this function back and forth, this parameter of this function back and forth, so on and so forth. Adding a push-up, thank you for that. So the first thing we need to do is create the function set, and we need to create it in such a way that we can we can modify it with time. That is to say, like we can, like we have the 6 elements that we can update. And we want to make it so, like, at any given time, we could modify some of the parameters. So essentially, we want to make sure that we're reading this in as the 6 parameters that we're going to update. Now, one thing I want to point out here is I don't think I have any sort of matrix multiplication. It is a 2 by 2 matrix multiply with a vector. So it's a vector matrix multiply, which is, there's essentially no reason for us not to unroll that into like this, like we did before. So I kind of feel like that's what we should do. We should just unroll it into, like, instead of like leaving it as this is a vector multiplication, matrix vector multiplication, we should just say, you know, each function has 6 elements to it. And then we just do like a function that's like apply affine transformation. So I think this is what I'm going to do here. I'm going to create a new apply affine, and here it's going to read in the vec point, and then it's going to read in another vector, std vector, I guess of float 64, no, of double, let's see, vector double, and we're going to say, should I call it transform set? Maybe I should call it parameters, maybe is what I'll call it. Go in here and there. Okay. How's this going to work? Okay, so I have to think about how we're going to save these 6 possible functions. So let's go in here. So we know that it's going to be some sort of vector v multiplied by, you know, a11, a12, a21, a22, plus I guess I'm going to say a13, and a23. So I think that's how we actually want to store it, as one big vector. And so I think I'm just going to store 1, 2, 3, 4, 5, 6, and I'm just going to notate that. And in here we're going to say, I guess under notes up here is where I want to say it. For all affine transforms, we are storing them as, I guess it's just going to be 1, 2, 3, and then down here I'm going to say 4, 5, 6. 4, 5, and then I guess I want a plus sign here, 6. I should probably start counting as 0, because otherwise it doesn't make any sense. Alright, we're going to change it to start counting as 0. So 0, 1, 2, 3, 4, and 5. Okay. So that we just have like what, you know, like what each element means, I guess, and this will help us when we're doing this like apply affine function. So now we can just keep a vector of double. In fact, it could just be, in fact, why don't we just do double star? You know, maybe that's actually a better way to do it. And then in here we're going to say return, okay, give me a second, I need to think about this. It should be point.x times, I want to say params of 0 plus point.y times params of 1 plus, 1 second, params of 3. Okay, and then we should be able to drop this down to the next line. We're going to say point dot x again. Let me make sure I'm doing matrix multiplication correctly. Give me a second. Params of 3 plus point dot y times params of 4 plus params of 5. Okay, and in principle, we should be able to say, maybe we want to say, now I don't remember the notation here, but I think if I just do the following, vec, we already have point. So why don't we just say point equals this, and then we return point. Something like that. There. You have param 3 on the first line, where you should probably have param 2. Yes, you're correct. Thank you. Okay, so let me just make sure I'm doing the matrix multiply right. So, this probably needs to be, okay, so I probably did this wrong. Let's grab this, and we're going to control X. And then we're going to move this over here, and then we're going to paste, move this up here. Okay, so I think it should be. So then we're going to say V here is going to be some sort of X element times Y element. So X, Y, and it should be A11 X plus A12, oh my gosh, A12 Y plus A13, and the next one should be A21 X plus A22 Y plus A23. Is that what I have written down? A11, A12, A13, yeah, I think that is correct, what I have written down. We'll see in just a second, but I think that's fine. So now what we need to do is reformalize all of our functions as affine transformations, which should be relatively straightforward, but we just have to make sure that we do it anyway. And then we should just be able to apply all of these affine transformations and recreate the Barnsley fern. But instead of creating an animation like we did with this guy up here, I just want to create one Barnsley fern without the animation to go with it. Just, here's your Barnsley fern, that's it, and have them all drawn already. And if we do that, presumably, we should be able to just kind of like twiddle some of these factors. And so I'll, yeah, I think this should be relatively easy to do. We just have to get it done. Okay, so the function set here. What I think we want is a double star star. But maybe I can do, oh, I just don't remember C notation. But I think I can do, there's going to be, how many functions? There's 4 functions with 6. Is this going to create, is this right? I don't remember C++ at all. 1 second. Yeah, I don't remember C++ at all. So I'm going to have to think about that. Do I actually, I could just use a vector of vectors. Do I want a vector of vectors? Yeah, I think I want a vector of vectors, yeah. A double variable name equals, correct, I'm sorry, I'm dumb here. Give me just a second. fx set is what I'm going to call it. Okay, and then we want this to be equal to, what I forgot was if I need curly brackets or not. That's what I forgot. Do I need to do, is this where I do this or something? That's meant to be a semicolon. I did this later. I just don't remember where I put it. Order for, yeah, so I think this is where I use the curly brackets. So what I'm actually looking to do is just create basically a set of zeros for now. So we just do 0, 0, 0, 0, 0, 0. That's 6. And we're, I don't want them all to be 0. Like, we know what they're going to be. So let's just go ahead and put them in right now. And then we don't have to worry about it. So I think if we do this, this should be okay. So what are the functions that we're going to have to put in here? It should be 0, 0, 0. 1 second. 0, 0, 0. Let me just take a look. Because they're already in that form if I look over here. Yeah, perfect. Yeah, in fact, let me just open up a new browser and just have Barnsley Fern up over here. And then we're going to get all the equations set and everything ready to go. Okay, so let's go here and do Barnsley Fern. Perfect. Great. Go down a bit. Yep, so there's all the equations that we need. So let's go ahead and put them in. 0, 0, 0, 0, 0.16, 0. So that's the first set. The next set should be, I don't know if I think this will work, but I might be wrong. So it should be 0.85, 0.04, negative 0.04. Hey, Scarce Moose, how are you? And then 0. Scarce Moose is different than Scarce Moose. I get that. 0.85. Oh, I actually missed some stuff. So it's going to be 0.4 and then 0.00. Perfect. And then 1.60. Yes, thank you for that. 1.60. So I think that's correct. That should be our 6 elements. And then we just have to do that again for the next 2 sets. So here and there, and I need to make sure I get commas as well. Comma there and comma there. Okay, so let's add this in. I would like to give you a riddle and would like you to participate in it since you seem like a perfect candidate. I'm going to be honest, I'm probably not going to participate. I'm so sorry. I don't really care for riddles at all. Like, I don't like puzzles. I don't like riddles. I just, like, I love research. I love figuring out, like, these types of puzzles. But if it's just, like, here's an interesting mathematical, like, here's an interesting thing. I'm like, I don't know, like, maybe it's interesting to you, but sorry, you can post the puzzle, and I'm probably just going to read it, and then other people in chat might be interested in it. But, you know, I probably will not do it. I'm sorry. Okay, so the next one is going to be 0.2, negative 0.26, 0.00, 0.23, 0.22, and then 1.6 again. And then down here, we're going to do negative 0.15, 0.28, 0.00, 0.26, 0.24, and 0.44. So that should be all of them as a set of affine transforms. And the nice thing about this is we should be able to just use the int fx number and int a number so that as we're modifying it, it should be fine. There was a cane in the rain without an umbrella, half wet, half dry. Most folks walked by. A kid, not thick, with shoes twice its size and googly eyes, found an umbrella. Both sunny and rainy, they should go together. Search the numbers 8639802 6. DNA combine your cane and umbrella. It appears to be little yet very heavy. One would call it xenon some set. Yet another color can break light without release. Releasing it, the name should provide another clue for your dark sense. With the last 4 heavy digits in hex, you release it some magic. When you crack the letters, go binary XOR, and you find what you're looking for. Once found, some number, carefully observe, as it will reveal the final for a few lucky. Okay, cool. So there's. Okay, I don't know. Thanks for that. It could be an ad. Calling a kid it. Well, okay, so, but actually this highlights exactly my point that I mentioned earlier. I kind of don't like these types of puzzles. Like, I'm sorry, it scares moose. I appreciate that, and I know that certain people definitely do appreciate it. Thanks so much for following. But it's not something that I particularly am interested in doing. And I do apologize for that. But I do know that other people in chat might be. And so, you know, maybe we'll find people to do it. But there's no need to participate. Yeah, I'm sorry about that. It's not, what I find, I don't know. I find, how do I put this in a way that like makes it sound like I'm not a complete idiot? It looks like a puzzle hunt or a hidden Google interview opportunity. Could be. Hey, I mean, maybe that's what it is. Gareth Moose is just like, oh, you know what? He could be a Google employee, and he's like, I'm just trying to find people to hire, and that's totally fine. But yeah, I mean, that's it. You need to make sure that there's like I don't know. I understand that you're not an idiot. I don't know. What I'm trying to say is the following. Like, here, actually, this is my explanation. Journal, new page before. Okay. Puzzles. There's a difference between a puzzle that you find on like the boundary of human knowledge, which is like something that you're doing with research, something that's new, something novel, something that no one's ever done before. And this type of stuff I'm actually really excited about, because it's like, hey, this is something no one's ever done before. But if it's a puzzle that someone has constructed for you, I get kind of angry about it in the same way that I get angry when it comes to playing games, for example. Like, I just get kind of like, if there's a set path that I need to take, I don't like taking that set path. And so for me in particular, it's frustrating. Like, it's fine. Programming is kind of fine because it's like a language to express your opinion and your ideas. But a lot of times, like, if it's just like a game, it's like, it's a puzzle game or something like that. I don't very much enjoy these because it's like, I don't know, it just feels like I'm just doing what people want me to do, and I'm trying to figure out what this person wants me to do, and it doesn't feel right. There's no errors in it. It's intended to be that way, the way it is. Could be, yeah, it could be that it. Anyway, good luck anyone that wants to try it. I will not be trying it, specifically not on stream. I'm, maybe posting on Discord as well. People might be interested, I guess. So anyway, that's the only thing I want to say was that when it comes to puzzles, I just don't. They're not my type, my cup of tea. Unless it's something new, something novel, something like publishable, something. There has to be some like clear reason for me to do it. And I don't know what the reason is, so I can't do it. Okay, let's go here, close there. Like, I don't think I've ever, like, nerd sniping, for example, doesn't really happen to me. Because, like, if someone else gives me, like, if someone else says, here's an interesting problem, I'm like, it's okay. It's actually not that interesting. Like, like, even if it's a research problem, I'm like, so, like, some person's like, oh, here's an interesting biological problem. I'm like, I don't care. Here's an interesting physics problem. I don't care. But then all of a sudden I'm like, oh, you know what? Fractal compression is pretty cool. Because, like, it's something that I came up with. It's something that I didn't think about anything else, You need half an hour and found me here on Twitch. Cool. Yeah, I'm happy to, if anybody wants to try it, go ahead. After I just rambled about how I don't like doing this type of stuff. I'm sorry. I'm being a bit mean. Okay. So we have this function set. So now we just have to do the chaos game. Yeah. So let's just go ahead and do it. So what do we have here? Barnsley quad transform. Barnsley here. Okay. So what I'm going to do is I'm just going to grab this guy and I'm going to move it up top. Yeah, I appreciate you coming in. And again, if you want to post it on the Discord or something, maybe people would find it interesting there as well. Because I do know a lot of people in the community do actually really enjoy the process of working through other people's, puzzles and stuff. So I feel like it is the right community to post that kind of stuff too, in some sense. Okay, so we have a point, apply Barnsley. I have so many apply stuff in here. Okay, so what I want to do is I want to do apply affine. It's going to be point, and then it should be function set of 0. And then we're just going to have to do the same for all these guys. Function set of 1. And then function set of 2 and function set of 3. Of 2 and then function set of 3 in here. And we're going to modify all these guys so they're apply affine instead of apply Barnsley. I think if I just do that, this should do. Yeah. Perfect. There we go. Okay. Now, what are we doing next? So we have this concept of a point. Do we have this concept of a point? We do not. So we have a vector of points. And I do believe we need to keep the entire vector, right? Or am I dumb here? Maybe we don't need to keep the vector. Yeah, maybe we don't at all. Okay, yeah, let's try doing this without keeping a vector. So we're going to do SV vector vec, and we're just going to say we're going to have a point. So PT is going to be equal to vec of, I think I use U0, 0. I believe that'll do. So now we have the point. And then we basically have some sort of random number. We apply the affine transformation. The location is going to be the world.size.x times 0.5 plus 200 times point x. World.size.y times 0.5 plus 500 minus 100 point.y. We say color, ball color is equal to that. We say auto ball is going to be equal to make shared ball color, whatever. So we don't need an animator in this case, I don't believe. No, we shouldn't. I think we can just keep adding the ball object, and then, yeah, and then we just update. Okay, let's see what happens if we run this. I'm fully expecting something to break, so we might have a few push-ups to do at the end of this. So let's do G++. Something's going to break. Yep, there we go. And let's just kind of work through these one at a time. Point was not declared in the scope. Totally fair, because it should be defined as vector. Vec point. Okay, do this one more time. So that was one push-up. Int main. Let's see. Void Barnsley. Error, a function is not allowed before. I missed a lot of stuff, didn't I? All right, let's clear a couple times, regenerate that message. Okay, error. A function definition is not allowed here before that token. So let's go to 183. I must have done something dumb. I did. Okay, so how did that happen? So Barnsley transform. Wait, what? How did that happen? 1 second. Increase difficulty of next set. Thanks, the silent tree. Appreciate that. So we are now at what? Difficulty 9? That's totally fine. Okay, so what do we have here? Barnsley transform. You missing a clue? Yeah, that's what I'm trying to figure out how I missed that because I didn't update Barnsley transform. So my question is, how did that happen? And I want to make sure I didn't break anything in that process, you know? Yeah. What did I do to make that happen? I mean, I can just, okay, well, let's just, for now, I guess I'm just going to have to do this because I did not commit it to Git at the end of yesterday's stream. So let's go ahead and do G++ one more time. It should compile. And so now what I'm going to do is just check the Barnsley transform function just to make sure it works. So let's do this and that, write this, and then we're going to run G++. And now let's just run /Barnsley and see what we get. mpv temp video.mp4. Right. Perfect. It's broken. That's kind of what I thought. Okay. Barnsley transform. I don't know how that happened. Okay. You should make a channel action that tells you to git commit. I almost always am like very, very like conscious about committing and stuff like that. But for some reason, just yesterday, I wasn't. I just was not on my game yesterday. Okay, so what's the issue here? We generate all the set of points, and then we... Oh, I see what happened. I totally understand what happened. Okay, so the issue was I didn't update the world at the end here. So I need this guy. But what is that? 6? And let's paste it down here. Okay, and then that should do it. Okay, go in here, run G++. And then /Barnsley. And now let's just make sure that works. Give it a second. I mean, it is rendering something, so that says to me it's doing something. And then I should probably commit this because otherwise I'm gonna, yeah. Okay, so this seems to do what we expect. Yeah, perfect. Okay, let me just make sure the other one's also working. Barnsley quad transform, for example. So this should do 4 transforms in a row. And just to make sure it's also doing what we expect. And yeah, MPV. That wasn't what I meant to do. I'm so sorry. G++. How many push-ups do we have to do? 10? Easy. Okay, MPV. I just compiled it when I needed to run it. I just run it, just for Pete's sake. Why do I forget simple things all of a sudden? Okay, so /Barnsley. Give it a second to compile. Let me see something. I just got a bunch of messages on some side screens and stuff. Okay. Perfect. Oh, man. 1 second. Checking everything. I am almost good to go. 1 second, sorry. Now I should be good to go. Okay. MPV. And we should see 4 transforms in a row. 1, 2, 3, 4. Okay. Perfect. Good. So we have the transforms all moving around. That's exactly what we want to see. So now the next one that we want to try is Barnsley twiddle. Okay. Barnsley twiddle. We want cam world. I guess 1,000. Whatever, 0, 0 for now. We'll worry about that later. Write this, go over here, run G++, and then hopefully we just see a fern. Like we should just see the Barnsley fern and nothing else. That's it. Okay, MPV. We see nothing, which is not what I was hoping to see. Okay, so we're gonna have to do some debugging and just see where it goes. Okay. There could be a number of different problems. Like it could be with the apply affine. It could be a number of different things. So what I'm going to do first is just output the location at every, well, no, output the point location. So we're going to do std cout pt.x, new tab, pt.y, new line. There we go, perfect. G++, / Barnsley. Okay, what do we, it looks like all these points are valid. I mean, they seem fine. You know, 1.7, whatever. I mean, yeah, it is a bit weird that the point.y never really varies too much, and the point.x doesn't vary too much, but, you know, we do have a bunch of valid points, it seems. So now my question is, why we didn't see anything? We were adding the object here, and the world.update I, ball color, vector location 0, 0. Oh, is that why? Okay, I think that's why. I think it's because, oh, nope, I don't understand. 1 second. So we're making shared, we're adding the object, we're creating the ellipse, the ball color is going to be dependent on I, which is fine, over N, also totally fine. Auto ball is going to be std make shared ellipse, ball color, location. Okay, let's also output the locations then. Script. dd paste, change all these PTs to locations. Change this also to a location. Go in here, try it one more time. G++. / Barnsley. Again, these seem like valid locations. They're all on the map. So I'm not seeing exactly what the issue is there. So we have all the locations being valid, I think. I mean, they're all supposed to be like 1920 in the map from 0 to 1920 and in the map from 0 to 1080, right? Because it should be a 1920 by 1080 canvas. And these all seem to be, you know, somehow in that area, which is fine. Okay, so we have the ball color, which is going to be also totally fine, I think, unless I'm really dumb. We make shared ellipse. Okay, let's just check to see what's going on when we actually do the Barnsley function. G down here, Barnsley. Yep. Apply Barnsley. Okay, so this should be the Barnsley function. So before I added an animator from 30, that changed the ball size. Oh, the ball size must be just completely non-existent. I got it now. 0, 0. 1 second. Barnsley twiddle vector point. Nope. Next. Oh, you. 1 second. Let me check that really quick. So let's change this to 2. Possible semantic problem in your if-else chain. You have fx set to case twice. You are correct. Thank you. That must have just been a typo, or it wasn't even copy-paste error. Like, I literally had to type that one in manually. Okay, so let's go here and let's just run G++. And then we're going to run / Barnsley, and hopefully we see something this time. Give it a second. It's taking a bit longer. Well, maybe not. Let's do MPV. Okay, hey! It's not a Barnsley fern. But, you know, it's something. Okay, so we have to figure out how it's breaking and why it's breaking in this way. But, hey, we're getting there. Adding a push-up, thanks for that. Oh, or did I already add that push-up? I don't think I did. Let me add a push-up just to be safe. Okay, so what I'm going to try to do is get this kind of working, just the first iteration. And then after the first iteration is done, we're going to take a break, do the 5-minute workout, and then, yeah, we can go from there. So let's do, what do we have here? Okay. So I don't exactly know why this isn't working. It could be a problem with the apply affine function, which is totally fair. We can create a quick test to make sure it's working as we expect. It could be a problem with the actual affine functions. themselves. Let's see. But one thing that does strike me is that this is clearly like, it is moving around. It's just moving around in a very weird way. So what I'm going to try to do right now is modify... Okay, so to check if it's a problem with apply affine versus something else, here's what I'm going to do. Paste, and I'm going to just change this to apply Barnsley again. Wait 1 second. And just see if apply Barnsley actually works for these guys. So this will be 0. And then we're just going to do that for all of these guys really quick. Okay. Comment this guy out. And this will let us know if it's a problem with the affine transforms, or if it's a problem with something else. I'm fairly positive it's a problem with the affine transform somehow. Let's write this, go over here, run g++, /Barnsley, and hopefully this gives us some sort of fern-like object. If not, then I'm not sure exactly what we need to do. Okay, so there's our fern. Perfect. Great. Okay. So this means there could be two problems. One problem could be in our definition of the affine transformations, or it could be in the application of the affine transformations. So let's think about it. Okay, so we have function set. Is function set 0 going to give us this? It should, right? Yeah, it should. Maybe there's a way to... I don't have good printing capabilities, but it should still be fine. So, again, we could have been putting in the wrong function set. Let's double check with that first. 85 0.04 plus 0. Negative 0.04, 0.85, 1.6. 0.2, negative 0.26. 0.23, 0.22, and then 1.6. Okay. Then negative 1.5, 2.8, 2.6. Yep, and then 2.4, 0.44. They seem like the right numbers. Yeah, they seem like all the right numbers. So it could be a problem with our apply affine. So when we're reading in the parameters here, maybe I just want to... Yeah, let's just try this really quick in the main function and just kind of do a quick test just to make sure everything's working as we expect. So I'm just going to grab one of these. I'm just going to grab this guy really quick. Move down here. And we're going to paste it down here. Change this just to be 6. And we're just going to say a test. All right, and in here we're just going to change these all to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then what I want to do is go into the apply affine function and basically just try it really quick. So we're going to say pt is equal to vec, and I believe I can just do 1, 1. Sure, it doesn't really matter. And now we're going to use the function. Apply affine. Pt is equal to apply affine. And then we're going to read in pt. And I realize I need to change the definition of PT really quick. And then a test. And here we're going to do vec. Go up here to a test for apply affine. And what I want to do is just output std cout params of 0. I know this is kind of weird to do, but I just want to make sure. I don't know. Like, I don't know exactly what's happening here. I kind of feel like point x, point y plus, point x, point y plus. And that's what we have down here, point x, point y plus, which is 0. And then point x, point y plus. I mean, it looks to me like we're doing the same thing. But, okay, let's just... Okay. Just do it. Output everything. Make sure we're not doing something dumb here. Params of 1. New tab. Okay. Actually, I want to do yank 2, 3, 4, 5. And this should be changed to new line. Okay. 2, 3, 4, 5. Okay, let's just see what this does. I'm going to go down here and just not run the Barnsley twiddle function. over here, and we're going to run G++. It's probably going to break. No, it didn't. /Barnsley. 1, 2, 3, 4, 5, 6. Okay. So now what I'm going to try to do is say a test of 1, 6. And we're going to do this and that. And now we're going to say a test of 0. G++ /Barnsley 1, 2, 3, 4, 5, 6 again. Okay, so we are apparently reading in the appropriate values. So I don't think that's going to be an issue. Yeah, I don't think that's going to be an issue. So it could be an issue with what we're outputting somehow. So point.x times 1 plus point.y times 1. Are we somehow going to be using, are we somehow casting onto an integer when we shouldn't be? Point.x times param 0. Param 0 is going to be the first element, which is fine. Yes. Plus point.y times params 1 plus params 2. And negative 0.04 times point.x. I feel like I'm missing something really obvious here, and I don't know exactly what that is. Which I guess is fine. You know, we'll just kind of, look at it. Yeah, we'll try to figure it out. I mean, I can just change everything to be 0.0, because I do have a lot of zeros here, for example. And so maybe I just modify all these to be 0.00. But I don't think that's going to matter, because these are cast onto doubles here. And then vector is defined only as doubles, or maybe float 32s, but you know, they're still always defined as floats. Let's see. Okay, so let's try the apply affine functions one more time. Run that. Okay. Again, we know that apply Barnsley worked just fine. Let's go down here, do Barnsley twiddle. Okay, and now we're going to run G++. /Barnsley. And I'm just going to check these guys to make sure that they are kind of what we expect. Okay, ran. Let me just run. Yeah, so let me just run MPV. Yeah, that's clearly not a fern. Like, no matter how you look at it, it's not right. So, let's see. What else can we do here? Yeah, I'm not really sure. So let's do. I mean, I guess I can output the point before and the point after to see, but we are outputting the point. We're outputting. Okay, let's modify it so we are no longer outputting the vector locations. So why is it going 5, 4, 5, 4? Like, why are these repeating in X? We are picking the same function a lot, but that's kind of okay because, you know, one function has like an 85% chance of being chosen. So it's not a huge deal that we're choosing the same function over and over again. I think that's kind of expected. Yeah, I think that's kind of expected. I'm just going to see if I can scroll up. Well, I can't scroll all the way back up to the top. I can't really right now see a difference between the apply affine function and the apply Barnsley function. That's kind of my problem, I think. Because right now the apply Barnsley function is literally doing point.x times parameter 0. Parameter 0 is going to be 0.85, and that's 0.85 plus point.y times parameters 1. and that's point.y times parameters 1, and it's going to be 0.85, 0.04. So again, still seems fine. Negative 0.04. I mean, maybe I just put some of the values in wrong. Negative 0.04 is params 3. That is the case, definitely. I mean, again, could be something with some weird integer casting here. So, but no, that's 0.00. These are cast onto doubles. Okay, let's just make sure the numbers are right again one more time. So 0, 0, 0, there's only 0.16 in number 5, which should be right. 0.85, 0.04, 0.00, negative 0.04, 0.85, 1.6. Cool. 0.2, 0.26, negative 0.26, correct. 0.23, 0.22, 1.6. Negative 1.5. Sorry, 0.15, negative 0.28, 0.00, 0.26, 0.24, 0.44. It looks right to me. I mean, unless I'm doing something really dumb. So we're gonna go ahead and take a second. Do the push-ups. I think we have 10. No, how many push-ups? 13 push-ups. Then we have 273 calf raises. So we can think about it while we're doing the calf raises. Let's go ahead and get started with that. And then we can get back to programming. So if you guys are here for the first time, well, okay, actually, it's been a while since I did this, so I do apologize for that. But I basically, at the top of the hour, every hour, we do some sort of just exercise just to, get the blood flowing, get the body moving, and kind of reset your focus on the problem at hand. And this is the perfect time to do that because honestly, I'm kind of stuck in debugging mode anyway. So it's good to just take a second, think about other things, and go from there. So let me go ahead and turn this off, go over here, go to some sort of music over here. 1 second. And I'm just going to put on some chill EDM music in the background, and we're just going to do some push-ups, some calf raises. Feel free to join me if you want, and let's just get that started. So give me just a second to move the microphone position, and I'll be right back. Okay, so how many... Oh, wait, why is the font weird? What's going on there? Anyway, I guess it's fine. So anyway, we have 11 push-ups and 273 calf raises. So let's go and do the 11 push-ups. Again, if you're joining from home... If you're joining from home, feel free just to do whatever you want to do. You don't have to do 273 calf raises because that's a huge number of calf raises. You can just do whatever you feel like. Just kind of get up, get a little bit of physical activity going, and then we'll get back to the problem in just a second. So 11 push-ups, 273 calf raises. Let's go. All right, push-ups first. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Wow. Okay, so now for calf raises, and I'm not really sure how to do this, so I'm gonna move the microphone really quick. You might hear a little bit of like a something. Sorry about that. Okay, so 273 of them. What do we have here? Okay, good. So let me just move the microphone slightly. Sorry about that. Oh, you can definitely... Okay. Anyway, so 273 calf raises. I was going to do... Let's do a set of 100, a set of 75, and a set of 100. That's what we'll do. Okay, so I'll go ahead and get started. Feel free to join from home if you want. Again, we'll just get some, rock solid calves. Can't really see them, but that's okay. And yeah, let's go. So, oh, I have a clicker. 1 second. I have a clicker specifically for this. Here it is, perfect. How do I turn it on? 1 second. Okay, so I've got the clicker. Ignore that little box of Oreos that I just moved around. Again, if you guys have any comments you want to talk about, feel free to do so. So, 100, 75, 100. Yeah, it's kind of been a while since I did, like, physical activity. Like, by that I mean, like... Wait 1 second, I'm watching the audio really quick. You guys might be able to hear me, like, moving around a bit. So let me move the microphone over here so you don't hear me moving the microphone. I'm going to have to check that after stream. So I'm going to have to lift this up a bit. Yeah, sorry, that might have been really annoying. Okay, so we're at 11, and I'll just kind of keep going. I'll be closer to the mic, maybe around here. But yeah, so I was doing, like, really bad with physical activity recently. Now you hear it? Sorry. Sorry about that, yeah. Okay, but yeah, I've been doing really bad with physical activity recently. Like, I should have been doing a lot better, but I just have not been. It has to do with, like, a number of different things. Like I said, my toe has just been awful recently. Like, really, really bad. When you're adjusting it. Yeah, sorry about that. And so, like, I wasn't really able to walk or anything, but today I was able to go around Boston just fine. So, it should be okay. How many is that? We're at about 50. We have a lot left. But yeah, if you guys want to just do something at home, work out a little bit, just get that physical, get some sort of motion going. We're going to have, like, really rock solid calves by the end of this. Holy cow. Who's that? 1 second. Indira Gandhi here. Thank you so much for following. Gandhi. Gandhi here. Sorry. Thank you so much for following. Really appreciate it. Also, let me move the camera so you can actually see me. That should do. A bit more. Okay, so how many are we at? We're at 65. We have a lot left to go. Soon we have 200 left. But yeah, feel free to join if you want. Do whatever you feel you're comfortable with. You don't have to do 273 calf raises. Just do like 10. That's already more than enough, you know? The truth is, I used to be, like, really good at swimming and stuff like that. Like, almost Olympic level times. And so, like, I kind of want to get back to doing that as well. So that's why my workouts are kind of a bit ridiculous, if I'm being honest. How many are we at? We're at 93, 94. So, like, I don't expect you to do, like, exactly what I'm doing. Just do whatever you feel comfortable with. That should be about 100. Okay. Gonna give myself just 30 seconds of rest. Then we've got a set of 75 and then another set of 100 to do after that. Again, the point here is just to kind of take a second, do some sort of physical activity, and just get ready to program again. Research stream caught my eye. Hey, can you let me know about what exactly you're doing? Yeah, we'll do that in just a second. So right now we're doing just a 5-minute exercise, just to, I don't know, just get the body moving and get back to it. So, a set of 75. But yeah, in general, what we're doing is some form of fractal compression. So, like, we are, what we're going to try to do in the end is basically take any image and represent it as a set of fractals. And that's kind of the overall goal of what we're working on. But to do that, we kind of want to talk about different attractors and different sets of attractors. And so one big attractor that people look at is the Sierpinski triangle, right? What we're looking at today is another attractor known as the Barnsley fern. And we're trying to get some really good visuals to explain how the Barnsley fern works. And so that's kind of what we're working on right now, just to kind of give a better picture of how all of the affine transformations for the Barnsley fern work together in order to create what is in itself a unique and interesting visual. And again, I'll show that in just a second. I've got a lot of calf raises to do because people lifted the difficulty of this from 5 to 9. So it's like on a scale from like 100 to 300 or something like that. And so like it's pretty close to 300 because people increase the difficulty a lot for this one. All right, we're at 160. I'm actually really glad I got the counter so I can talk and just like do the calf raises at the same time. My calves are burning. This is really tough. All right, 71, 2, 3, 4, and 5. All right, so I've got one more set of 100 left. I'm gonna do a quick stretch. I am so sorry. Give me a second. Geez, that's tough. All right, one last set of 100. And yeah, I'll go ahead and start. I guess one note on calf raises. Okay, so a friend of mine, we used to do like a relatively rigorous exercise set, where it's like, Monday was chest and triceps. Sorry. Like Tuesdays would be like biking or something like that. Wednesdays would be leg day. Thursdays would be like jump roping or running or something like that. Fridays would be back and biceps. So we had a relatively good workout routine going for us. And I will say that after leg day, the muscle group that hurt the most it wasn't like quads or anything like that. No, it was definitely calf raises. From just doing like a set of, I guess we only did 150 calf raises at a time, but it was like on an incline, so you could get more of the motion of your calf. So, I don't know a lot of the technical terms you used, but I understand the bigger idea. Would love to learn about it. Yeah, so we'll talk about it in just a second. We obviously have a bit more to do. A bit more calf raises to do, but we're almost there. We're at 233. So about 40 more or so. Oh gosh, this is tough though. I'm gonna take a 2-second break, or like a 2-minute break after this is done too, and then we'll get back to programming. So, and reset the counter and all that kind of stuff. So my problem is I always get like foot cramps in the middle of doing this, not calf cramps, foot cramps. All right, we're at 53, 4, 5, so 20 more. Let's see. But yeah, my feet are really struggling here. All right, how many more do we have? 5. So last 10. All right. 7, 8, 9, and 10. Okay, so that's it for that. We did 275, not 273. A bit more than we were supposed to do. That's totally fine. Give me just a second to move the microphone position, and I'll be right back. Okay, one more second just to make sure everything's set, but yeah, the microphone position's back, so. All right, let me catch up on chat. Yeah, I do agree. I think it's better if you step on something higher than with your fingers. Something higher with your fingers. Yeah, I agree with you there. I just didn't have it. Okay, so I'm going to take just a 2-second break just to fill up on some water. But then I'll get back to doing the research project in just a second. So let me go ahead and change the music back to this one. And yeah, I'll be right back. Oh. Yep, 1 second. I think I knew what you meant. Like, I thought, like, I knew what you meant in that you want to go on an incline, and I normally would. It's just that I didn't really have an incline that was, like, readily available for me at the time, so I didn't do it. Okay, let me modify a few things. The first thing I want to do is change the set and reps to be cycle set. So the next one is going to be... Next one is going to be leg lifts, 150 leg lifts, which are the It's just an ab exercise just to lift your legs, which are different than calf raises. It is a bit confusing. Okay, and then I also need to reset the push-up counter to 0. Okay, perfect. So now, quick introduction to what we're doing here in case people weren't here for the past hour. Or are maybe interested in like what the research project is that we're doing and all that kind of stuff. I'm going to go ahead and CD into projects. Actually, one second. CD into videos, algorithm archive, iterative function systems, Alice here, and I'm going to run mpv Sierpinski Hutchinson.mp4. Okay. Also, let me check something really quick. Is my voice clipping a lot? I just realized that when I was looking at the workout stream, I kind of feel like my voice is clipping a bit. If you guys are hearing clipping on your end, let me know so I can fix it, because that would explain like some stuff. So sorry about that. Okay, so essentially what I want to show here is a very simple animation for creating the Sierpinski triangle. So we start with 3 points A, B, and C, and then 3 initial points D, E, and F. What we're going to do is we're going to create 3 functions. One will bring you halfway towards A, another will bring you halfway towards B, and another will bring you halfway towards C. The idea here is that we're going to basically be moving the children of D, E, and F, towards A, B, or C. So if we watch this, 3 will go towards A, B, and C. And then, if those children have children and those children have children, and they all kind of follow the same pattern, you eventually create the Sierpinski triangle, which is just a triangle of triangles like this. So this idea of kind of iterating through a function system in order to create some sort of weird shape is known as the iterated function system. And one way in which we do this is through something called a chaos game, where instead of following all possible children as they're moving through all possible paths, what we do is we choose like some random point, let's say maybe a random point here, and we have it select a function at random to move with. So it could move maybe halfway towards A or B or C. And the next time it will choose another function at random. It will just keep trying to choose these functions at random until eventually it does land on the Sierpinski triangle. And when it does, it can't escape. All subsequent points will be on the triangle. And so this idea of kind of following a point and having it go through a million different iterations before we get the Barnsley-Fern or Sierpinski triangle is kind of the idea of an attractor and a chaos game. And what we're focusing on right now is kind of a few related questions related to this. The first question is, can we use this to compress an image? The answer is yes, called fractal compression. But can we do it better than like the previously known methods of fractal compression, right? So that's kind of one research question that we have. Another research question that we have is like, if we take an arbitrary point, like some point over here, how do we know how far away that point is from the Sierpinski triangle? Which is a surprisingly difficult question, because even though we see, a line of red dots here, a line of green dots here, a line of blue dots here, in actuality, these aren't points, or rather they aren't lines, they are just a selection of points. And so we're actually talking about a lot of relatively dense set theory in order to like fully understand like how and why this point is sufficiently far away from the Sierpinski triangle and stuff like that. So what we're working on today is something that's a little bit on the side, but still very related, and that is understanding how the affine transformations for another iterative function system known as the Barnsley-Fern work together in order to create the fern. And so that up here, what you see in the upper corner, this is the Barnsley-Fern. And you'll see that, if we do the chaos game, we basically get a whole bunch of points like this. So what I'm trying to do is I'm trying to create a bunch of set of functions to kind of help people understand how the set of functions that we create with the Barnsley-Fern, or the Barnsley-Fern is created with, will actually create this structure in the end. So that's kind of what we're working on right now, doing some visuals and stuff like that to try to make everything work out. Right now we're in heavy debugging mode because, quite frankly, my Barnsley twiddle function, as I called it, it's not twiddling. It's not working at all. So we got to figure that out and figure out why it's not working and go from there. But once we get a very simple visualization working, we should have no problems going from our simple, straightforward, and like Barnsley twiddle function to a function that allows for us to kind of like move, modify the affine transforms with time. Hey Trash Talk, how are you? I hope you're having a great day. Okay. So let's just try to figure out exactly what's going wrong. So just to catch everyone up, if we go over here and we run mpv temp video to mp4, this random scribble down here at the bottom is really supposed to be a Barnsley-Fern, and it's not. And I don't exactly know why it's not. So that's kind of where we're at. So we have this Barnsley twiddle function, and and it's just not working. Just a conversation about patent rights. Oh no, that sounds awful. I'm sorry about that. Yeah, patent rights, anything with like licensing and stuff is always just a pain in the butt. Like I kind of understand why we're in this like the complicated, landscape that we're in. But yeah, regarding the COVID vaccine. Now that's an interesting one. Yeah. Yeah. I don't really know much about that. Okay. But yeah, feel free to talk about it. I have not seen the news. Could you send the news? You have 0.85 instead of 0.85. Do I? That could be it. Let's go ahead and modify that. I'm just bad with numbers. Write that. Go over here. Run G++. Perfect. / Barnsley. Sorry, I have a lot of cout statements. And then run MPV. There you go. Perfect. Thanks for that. I just spent the past 10 minutes, or like 10 minutes before the workout part, trying to figure out how or what the numbers were. But that's it. That's what we needed. Thanks for that. So let's go ahead and modify this so we no longer have the cout statements, and we're going to commit that to GitHub. And then we're going to work on the next part, which is going to be actually modifying each of these functions with some random variable. So let's go ahead and do that. So let's see, Barnsley quad transform. There should be a cout somewhere else. I don't remember where. Here. Perfect. Write this, go over here, run G++. Okay, now we're going to run just / Barnsley and MPV just to make sure it's working. Give it a second. Okay, yeah, and then MPV. MPV. Good, okay, so there's our fern. Looks great. And we can go from there. Thanks for that, by the way. Take a look at that link in just a second. Let me commit to GitHub. So git status. Oh, no. Clear. Git add. I think barnsley.cpp is what I want. Git commit -m. Fixing Barnsley fern. Visuals. Adding more Barnsley visuals. Working on Barnsley twiddle. Okay, perfect. Git push. Origin master. All right. Take a look at the link. Okay, over here. Paste it there. I think there's a Q I missed. Okay. Why patents on COVID vaccines are so contentious? Is this accept, I guess? Is Johnson like, is this Johnson & Johnson? Or is it a different Johnson? Why is patent project so important to drug makers? Wait, what's the actual headline news here? Like, I mean, the vaccines are still like available for everyone, right? Like they didn't like take a vaccine off the market because it was no longer like patentable or something like that, right? Because otherwise, like, I don't know. I mean, I will be getting my last vaccine shot on Tuesday, so Biden suggested waiving the patent for COVID vaccines. Okay, waiving. I see. I don't fully understand. Okay, right. So the idealist in me says that's not a problem. Right. Just accepted a Vue.js dev role. Should be a good time. Yeah, good luck with that, honestly. Vue is a really interesting, like, open source project, specifically because Evan Yu, I think is the guy's name, who's like the mastermind behind it or whatever. Like, a lot of his stuff it's an open source project, and he's like majorly crowdfunded because of it. So I don't know, it's like a really interesting model for programming and open source development and stuff. So so like the idealist in me says, this is probably a good thing to do. I don't know what you're going to call it, but the, rationalist in me or whatever, understands that this is just not something drug companies are going to do. Like, I wish they would, but they're just not going to. Pragmatist? Yeah, maybe. Okay. So we have that working. Let's go ahead and do a very quick twiddle. What I mean by this is I'm going to take one of the transforms, and I'm just going to modify one of the variables of the transform and just see what happens to the overall results here. So how are we going to do this? So what we're going to do is, I think we're going to update. Yeah. So I think that's how I want to do it. I'm going to be adding a lot of points at the same time, but maybe that's the best way to do it. Okay. So I'm going to take this for loop and I'm going to split it up. So I'm going to do, dd here. I'm going to paste it up here. And I'm going to modify it so the inner component is now j. I could have done this all at once, but screw it. Okay, world.update, and then I want to put world.clear up here as well. And I think that means that we're probably going to have to. I think there's a clear layer function, and so I think I just want to do world.clear layer. And I want to clear layer 1. And I think that's how you do it. I'm pro waving pattern in this case. Yeah, twiddles are fun. Yeah, that's the thing. So the tilde, apparently a lot. So let me just Google this really quick. Twiddle. To play negligently with something, fiddle. That's not what I meant. Yeah, so a lot of people call the tilde the twiddle, and I don't know where that came from, but it's something that I kind of subscribe to as well. I kind of like calling it the twiddle instead of the tilde, like x twiddle would be x tilde. Okay, so we should just be able to clear that layer. I think this will all work. Yep, so let's run this, and I just want to see how long it takes. Oh no, this could be awful. Time. All right, let's see if this takes a super long time or if it's done relatively quickly. So what time is it actually right now? So it is currently 5:26. Oh, is it done? Okay, let's run MPV. Yeah, perfect. Okay, that's way faster than I thought it would be. I'm happy with that. Relatively happy with that. Okay. So now we just have to create a twiddle variable and twiddle the appropriate set. Twiddle / bang splat. I don't really know. But yeah, I agree with you, Trash Talk, in saying that I also, like, again, am in principle for waiving the patent in this case. But I do understand that it's not going to be the case, Yeah, this was definitely a Christmas tree. In fact, if we increase the number of points, let me see what happens if we increase the number of points really quick. I just want to see how bad this is with, so let's increase the number of points by a factor of 10, because the last one took 40 seconds. So this one should take 400 seconds, which is 5 minutes or so. Let's just see what happens. G++ / Barnsley, and I'm going to time that as well. I just want to check the scaling really quick. And I also want to see what it looks like as we like modify the leaf with a larger number of points. So if this takes 10 times as long, then it should take 400 seconds, and that is 7 minutes. So we might have some time to chat. If you guys have any questions, comments, concerns, ideas, anything like that, feel free to let me know. Totally happy to talk about anything at this point. But yeah, I'm so much more like, oh, it's done. Never mind. Please don't. Yeah, please don't say anything in chat. All right, let's see what happens. I'm going to run MPV. I think it's fine. Yeah, this is fine. Like, it looks kind of like a staticky, old school staticky image, but it's fine. I don't mind it too much. Okay, so I'm going to drop it back down to 1,000 points, and we're just going to twiddle something. I wonder if this is used in mirrors. I have no idea what you're talking about. I'm just completely lost as to where that comment even came from. Okay. So we have the set of functions. Let me go up to Barnsley Twiddle. So now all I have to do is create a double variable, which will be the twiddle variable, twiddle val. I don't know what to call it. Double twiddle val equals 0. Perfect. I don't know how the time scaling works. You see how the pattern goes in infinity, likewise in mirrors? Okay, that is a good question. So if you put two mirrors back to back, you'll get the image, consecutively back. Like, so the self-similarity is there. The way in which you generate the self-similarity in an iterated function system is remarkably different than the self-similarity in a mirror. But maybe there is a way to, like, like think about mirrors in a way that you would typically think of fractals. I'm not really sure, but potentially, right. Okay, so twiddle val here. So we have the function number, we have a. So what I want to do now is I want to make it so every iteration I, we're going to modify the twiddle val. So we're going to say twiddle val, and I want to go up to 0.5, back down to negative 0.5, and then back to 0. That's what I want to do. So it's going to be equal to, okay. I might just have to, if I is less than, I'm just going to have to create some weird if statements. Have you done anything else other than leaves? Yeah, like for example, we have the Sierpinski triangle, and we also have, like, you know, we have this guy. Here, there's another visualization that we made of the Sierpinski triangle, and we also did visualizations of fractal flames and stuff like that. I think that calling Barnsley twiddle is not that long, but that setup time is relatively huge. Yeah, I think you're right about that. I was expecting that the point for every frame, like the generation of every ellipse, would take a while. Let me cd project into f flamify. L is here, and let's just do mirage save 1.png. So we also generated images that look like these, which are like a combination of a bunch of different fractals put together. And so you can make a whole bunch of different images with them, but we were just kind of testing it and stuff. So, but we're leading up to that. Right now, we're still kind of in the background, working on understanding like just a simple transform, and having a good way to visualize that. And so that's why we're going from the Barnsley fern and the Sierpinski triangle first. So that's where we're at. Sacred. I don't know how it's sacred, but I guess that's good. Okay, so if I is less than, I guess we want... Okay, so here's where I'm getting a bit iffy here. So I want to say if I is less than, I'm going to go up here and just say frame number. Frame num is going to be equal to 600, which isn't, okay, this is the wrong way to do it. I should probably read it in as a function argument, but I'm not doing that. So, yeah. So if I is less than frame num over 4. Okay, now we need another else if statement. Now I always forget what else if looks like. Never mind, it's right down there. Else if I is greater than or equal to frame num over 4, but less than, and I is less than frame num over 2. Let's actually get these guys right. Perfect. Down here. Now we need another else if, which looks similar to this. Yank to yank. Paste in here. Is greater than or equal to that, but press the wrong button. I guess 3 over 4. 3 times over 4. And then finally, I'm an idiot. There. And then I'm actually just going to have the last one also be an else if. Yank to yank. So else if frame number I is greater than frame number, greater than or equal to 3 times frame number over 4. I'll catch up in chat in just a second. Okay. What do we have here? Is this C or something? It is C++ right now. The visualization library is GathVL. Gathros, who is a member of the community, was the one who basically spearheaded this entire operation. He had help from another member of the community called Gustorn long time ago. And then, I just wasn't very active, and they are no longer active because of that. But on the other hand, it's a really good visualization library. I quite like it. Okay. So what I need to do is modify the twiddle number. So here we're going to say... twiddle factor value val is going to be equal to, so this one's going to go up to 0.5. So it should go 0.5 times, Boxman1, thank you so much for following, really appreciate it. It's going to be I times, I'm bad at this, give me a second. I times 0.5, oh geez, why do I suck so much? I times 0.5 divided by frame num over 4. I probably shouldn't be using divisions. I know I should be using multiplications. Give me a second. 0.25 times frame number over 4. Let me modify all these guys to also use 0. 0.25, multiplications instead of divisions. Now, I do understand, for most programmers, there is no difference. I agree. It's been drilled into me because I do so much scientific computing that, multiplications are slow, but multiplications are fast, but divisions are slow. So I am fixing that right now. So, yeah, 0.75. There and here. Oh God, my spacing is all over the place. Give me a second. I'm not even trying in terms of keeping my syntax regular. So 0.75 times that. Okay, perfect. Oh, geez, whatever. Okay, perfect. Okay, so what am I doing here? It should be 0.5. Oh gosh. So I will go we'll go from 0 to, I will go up from 0 to whatever a quarter of frame number is. So that'll be 0 to 150. So it goes up from 0 to 150. And as it goes up from 0 to 150, we're basically scaling 0.5 value. So I think that's totally fine. So now for the next one. So this one should go from 0.5. So 0.5 minus some number. And this is going to go from I want to say it's going to be I minus 0.25 times Astromax1503. Thank you so much for following. Really appreciate it. 0.25 times what? Chotomate sumimasen. Frame number. Okay, so what this is going to do is I is going to start at 150 in this case, and then we wanted to count back up to 150 again. So we want to go from 0 to 150. To make it go from 0 to 150, what we need to do is we need to subtract 150 from it, which is 0.25 times frame number, and then we'll go back up from 0 to 150. Perfect. Yes, this is what I want to see. Right. Okay, so now we're going to do yank and paste down here. Okay, in this case, it's going to be starting at 0, and it's going to be going negative, so we're going to start at 0.0, and this is going to be minus 0.5 times frame number. Yank and paste in here. And this is going to go from negative 0.5 to what? What am I doing with my life? 1 second. I minus 0.75 plus. That should do it. I think this is right. So what I'm going to do is I'm actually going to output this. skd cout twiddle val new line. Let's see what we got. So we're on G++. Right. Okay, let's set some push-ups. Floating point is not that fast, and division by a power of 2 is compiled to right shifts. Yeah, well, Okay. What do we have here? I guess we are dividing pretty much only by powers of 2, so it's probably fine. I forgot a whole bunch of semicolons. That's what I forgot. Oh. Let's go there, there, and there. Try it again. World update of I. Where's this error? It says else without a previous if. Did I just forget how else ifs work? Oh, no. I see what I did. I forgot to do that. Okay, so that compiled. Let's run /Barnsley. Okay, so I probably should have done fewer frames than 600. Yeah, let's drop this down to be 100 frames. Just for testing. Try it again. G++. /Barnsley. Okay, so let's see what this did. We should see it starts at 0, and then it goes up to 0.5. Yep, and then drops down to 0. Perfect. And then drops down to negative 0.5. Which it does. There it is, negative 0.5. And then it goes back up to roughly 0. We're off by 1, but I think that's okay. Okay, so that should be fine. So now let's change this back. Oh, let's actually leave it at 100. And now what I want to do is modify the twiddle val, or modify one of these elements appropriately. So what I'm going to do is I'm going to say function set. Oh, I see what's happening here. Right. So what I'm gonna say is previous val. Oh, it's a dumb way to do it. No, here's what I'm gonna say. Double mod element, modified element is going to be equal to fx set, and then we should take fx number, and then we should take a number. Okay, so this will give us our modified element, and then in here we're just going to say, what am I doing? Fx set of fx number of a number is going to be equal to modified element plus twiddle val. Okay, in principle, this I think should work. Okay, let's go over here. We're run g++. Now we're just gonna run /Barnsley and see what happens. Okay, so now if we run mpv. Okay, something happened there, but it's really difficult to see. So let's do it one more time. By increasing this guy to 10,000 again, because that one didn't seem to work so poorly. And let's go back up to the start here and change our 100 to be 600. Okay, so now we're going to run it one more time, g++ /Barnsley, and now we should be able to update pretty much every single one of the values for every affine transformation, so we can check to see what everything does. Yeah, is this a good idea? Probably not, but it is an idea that I want to try, and we're going to see what happens. So right now what we're modifying is the upper left-hand element of the transformation that basically gives us the stem. So what we're hoping to see is kind of I think we're looking for a scaling along x of the stem, I think is what we're looking for. So let's take a look at MPV. Okay, now that's interesting. Okay. Right, so it's kind of hard to see, but if you look at it one more time, what we're actually seeing here is here we have our stem, and we're actually seeing a small leaf being generated at each of these stem points, and it's kind of moving left, and it's moving right. So, I don't know, I think that's a pretty cool visualization. Alright, so now I want to modify some other points just to see what we got. Because that seemed to work, like we do have something modified every step. So what I want to modify next, I want to modify, what are the affine transforms that we have? I'm going to modify the 0 point, this one, and we're going to modify, no, we want to modify that. Okay, let's try it one more time. So we're going to run g++ /Barnsley, give it a second to do its thing. It seems to be chugging a bit more this time, or am I just bad at... No, what? Why is it going faster now? Anyway, it's fine. Let's just give it a second to do its thing. And then we should get a new visualization, which should allow us to see the tree changing, or the fern changing, a bit differently. Let me get some water. Okay, it's done. Let me run MPV. Ooh, look at that. That's a thing. Interesting. Cool. I guess. Should I just go through all of these visualizations, just one at a time, every one of them, and just generate every single, like every single possible movement? I think I should. Okay. I'm going to increase the number of points here, and I'm going to see how long this takes. G++. /Barnsley, I'm going to time that. It's going to take a lot longer. Holy cow, I should have known. There's 600 frames. It's taking like half a second for each frame, which means it's going to take 5 minutes. So this one is going to take 5 minutes. If I was going to... Okay, let me see the resolution of this one at the end. I'm going to see if we want to do this. I'm probably going to have to do all of these overnight, is what I'm seeing. But we have the function working, which is great. So that means that we can now kind of like see how each of those... we can now see how each function... modifying each function will allow us to change the fern, which I think is quite cool. Like, it will be a cool visual. Whether it's actually useful for people or not, I don't really know. But again, yeah, maybe having a cool visual is enough. We are actually getting up on halfway done with the visual. Again, guys, if you have any comments, questions, ideas, anything, concerns, anything like that, feel free to let me know, and I will totally address it as soon as I see it in chat. The next exercise looks like it's 150 leg lifts, so maybe we generate a few of these guys while we're doing the leg lifts, just to kind of see what it looks like, and then I can generate the high resolution versions of them when I am... yeah, so we can generate the high resolution versions of them like when I'm sleeping or something like that. I do a lot of my rendering when I'm sleeping. That's just when you do renders, right? So to do that then, let's go back over here, drop this by an order of magnitude. We're going to say 4. I equals, 1 second. You should put together a meta visualization with all the X forms in a grid. Yeah, this is what I was planning to do, something like that. I was in fact planning to do exactly like what we did for the affine transform, where we have the function that we're modifying, and then we just kind of have the variable that we're modifying with it. And I was going to put a dial on it and everything. I'm not really sure how I want to do this. Like, these visuals took a long time to make. So if I want to make them again, it's going to just take a while, and I don't want to, I don't know. So I have to think about how I want to do that. Yeah, I have to think about how I want to do that. Like, I could just spend all day on Saturday just remaking the visuals, but something like this is what I was anticipating. I do feel like maybe putting an algorithm archive article out for this as well would be useful. So I'm debating whether we want to create like algorithm archive versions of these visuals as well. Like, you know, like with white background and then the image color being slightly different. But we'll see. We'll see. These visuals were annoying for other reasons. So I don't know. I was just thinking of matching up speed scale and putting them all on a grid in one simultaneous video. Right. That's again kind of what I was anticipating doing. Okay, so let's go here, d, and then we'll set the for loops in a second. Let's run MPV. This is a nice visual. Like, does it help anyone understand what's happening? I think so. Yeah, I think so. It helps explain what each visual, like what each function is doing. I don't know. I quite like it. I like it, actually. I think it's quite nice. Yeah, that might be my favorite visual that we've generated so far. Yeah, I like that a lot. Okay, let's go ahead and I'm going to move this over. So move temp video.mp4 into Barnsley, I don't know, Barnsley twiddle 1.mp4. And I'm actually going to have that one playing in the corner from now on. MPV Barnsley twiddle 1.mp4. It's a nice visual. I mean, like, again, it doesn't work very well unless you have all the visuals together, but it looks pretty, you know? You have to give them that. Loop 0. Okay. So there is a bit that we have to do to make this so people understand exactly what we're doing, but hey, we're getting there. Does it let you suggest how to tweak parameters to make Sierpinski? Yeah, this is kind of what you're trying to do. Like, what I'm trying to do is get a more visual understanding of what each transform is actually doing. Like, that's what I want to do. And so, having this type of visualization, I think really helps with that. But yeah, making a spikier or more diffuse friend. Okay, so what I'm going to do right now is I'm going to actually create a quick for loop here in the main function that will allow us to create lower resolution versions of this guy for twiddling every single parameter, right? And then create like a meta video to go with that. What I want to try to see is what happens if we... I guess I just want to create a bunch of different videos at the same time. Yeah, I want to create a bunch of different videos at the same time. Yeah, so that means we're going to have to do some sort of stupid string manipulation, aren't we? I don't like doing string manipulation in C++ at all, but that's okay. So, for int I equals 1, I equals 0, sorry, I less than 4, plus plus I. All right. And we're gonna have to do the same for j. For int j equals 0, j less than 6, plus plus j. Perfect. Okay, and now this is going to be modified to ij. Okay, so this will get us through all of them, and now we just want to modify the encoder here. So let's go ahead and yank and paste this in here. Perfect, and then we're going to have to clear encoders also every time step. Paste in there. So what I want to do is quickly move these guys around up there, and in here, comment that out, comment that out. Okay, so now we just have to get the video name. So in here we're going to say std string. Well, maybe there's a better way to do this. String. I guess we could do like sprintf. C++. I'm sorry, I really am like awful with this type of thing. So buffer. So can we just do sprintf? Can we do, okay, 1 second. We're gonna have to do some tests here. So I'm gonna comment this entire block out. I'm so sorry. And here what I'm gonna say is std cout, sprint f of hey, d, and then I think 1, 2. Let's see what that does. Fix the end of the block comment. Thanks. Okay, I think that's right. Probably wrong. That's okay. So let's go here and run the last g++. It's gonna break, certainly. Yep, definitely. Let's add a push up for that. Let's see where we're at. sprintf. No, I don't think I want to print it out. Character buffer. Printf. No, maybe this isn't what I want. I just want to modify a string. We have to give it a buffer. Why do we have to give it a buffer to write to? Okay, let's just do modify. That's great. How to modify a string function? Okay. Yeah, I don't know if that works with a string or if it only works with char. Screw that. Get rid of that. 1 second. Yeah, so I need. I mean, okay, so that means let's try this then. Let's just try it with string and see if it actually works. So std string. No, that doesn't make any sense. No, that definitely doesn't make any sense. Okay. How do you do the percentage s and c? Printf. Give me a quick. Okay. Characters. So what's the 65 do there? Okay, let's try printf instead of sprintf. Okay, that didn't work because... Oh, printf, I just want to modify a string. Okay, I guess sprintf probably modifies a string. Okay, I mean, I could just do... Okay, let's see, printf that. So this will print to, like, I want to modify a string. No, I want to... What do I want to do? Let's go here. Okay, maybe that's it. Printf that string length. Yeah, how do I know what the string length is, though? That's my question. Don't mind if I just join it together? Yeah, so I don't know how to do that. That's the other question. Like, that's what I'm trying to do. So how do we join strings? concatenate C++. Okay, can you just add them? Okay, so then we just have to find a way to convert int to string. If we can just add strings, that's what I was actually looking to do. So let's do file base equals this guy, temp video.mp4. Okay, and now what we're going to do is std cout file base plus file base. G++. Yeah, of course that's not going to work. Oh, no, it's not going to work because I'm done with strings. G++ /Barnsley. Perfect. Okay, so now all we have to do is go in here and say file base. Oh, there's .mp4. File end. File end. It's just a .mp4 at the end. And this is all the way up to the mp4. So we're going to do file base plus, and now we just have to turn an integer into a string. I'm sorry, this is really messy. I'm sorry. C++. Oh no, this is like the worst. Okay, toString C. Okay, file base plus toString of I. Is this going to put them in the right order? Yes, it will. Is this string theory? No, it's way more complicated than string theory. It's actually dealing with strings in C++. I say as someone who has actually taken a string theory course and genuinely believe this. Okay, let's go here, move that down here. Okay, in principle, this will do something. Okay, so what I'm going to do next is I'm going to go in here and check the next cout. There, I'm not going to have it print out the twiddle val. Instead, what I'm going to do is have it print out I and j on the interior of these loops. So std cout. I guess actually probably what I should do is say std string, not strong, string, file name is going to be equal to this guy. And then I need to have a plus sign. Good, I found that out now. And then here, oh no, it doesn't, whatever. Move these down to the next line. And then change this just to be file name. $, file name. Here, and then I just want to output the file name. std, oh, is it std toString? Yeah, I probably do need std. It's C++. It's filled with stds. All right, there, write this, go over here. Just run G++, see what happens. It compiled. Okay, so now I want to output the file name at every step. So std cout, file name, new line, write this, go over here, run G++, and then hopefully it works. It didn't output the, oh, it did, video00.mp4. Give it a second and see if it outputs video01.mp4. That's what I'm looking for. I want 0, 0, 1, 0, 2, I want 0, 0, 0, 1, 2, 3, 4, 5, 6. Ryder Chauncey, thank you so much for following, really appreciate it. And then I want like, I just want all the videos, this is what I want. So we'll see if this actually works. And it is, perfect. I like how it says copy left. Wait, where does it say copy left? I'm so sorry. Oh, is one of these guys copy lefted? Oh, it is copy lefted. What? This codec is copy lefted? Whatever. It's fine. Okay, let me get some water. Okay, so while this is running, I think this is the perfect time to go ahead and do the exercise for the hour. So we have 150 leg lifts and 5 push-ups. I'll go ahead and do that. So give me just a second to change the microphone position. For those of you who may not have been here before, I started doing basically an exercise on the hour every hour, just to, first of all, get more excited, like just to increase my enthusiasm and stuff, because quite frankly, I am like entirely like, I don't know, I just need something to get my motivation levels up. More than that, it also allows me just to take a second, focus on something else, get myself to be a little bit more physically active during the day and stuff like that. So if you want to join, feel free to join. I'm going to be doing 5 push-ups and 150 leg lifts. It'll take maybe 5 minutes, and then we're going to get back to the programming after that is done. I will say that next hour I probably will not be doing an exercise because I have to leave at 5:30, and so if I do the exercise, I have to leave at 5:15 because people are coming at 5:30, and I have to prepare for when they're coming. It doesn't make sense just to do the exercise and go. So this will be the last exercise for today. I won't be doing it again at 5 o'clock. So also, I do apologize for all the streams recently being like at most 2 hours. It's just that because I'm moving from here at the end of May, like I've been having a lot of trouble just getting all the paperwork completed, doing stuff with Grant, and then like the realtor comes by like every day, bringing people in to see the apartment, which is fine, but also it means that I can't do super long streams. So one of these days I might just like, I don't know, maybe one of these days I'll just be like, screw it. I'm going to keep streaming while they come in, and I'm just going to like put the Laos is doing something embarrassing screen up if they come by and I'm in the middle of streaming or something like that. I don't know. Like it's getting kind of ridiculous where like it's always right in the middle of streaming and stuff like that. Anyway, we're going to go ahead and do the exercise for today. Again, for this hour, again, you can join if you want. You don't have to if you don't want to, but we're going to go ahead and get it done while this is rendering. It's a perfect time. So I'm going to go ahead and turn this music off here. Turn on some, oh, that's not what I meant. That's also not what I meant. Where's the music? There it is here. Turn on some chill EDM. And I'll be right back. Just let me move the microphone position.
Didn't wanna go, 'cause out here I'm all alone. Didn't wanna go. I wanna turn back the time and let you know to come home.
Okay, good to go. So, for those of you guys who may not have been here before, you guys don't have to join me with the push-ups. You don't have to do it if you don't want to. It's just something to kind of get everyone to be a little bit more physically active. Let me go ahead and change my, stream manager so I can see chat. And it's just going to be 5 push-ups, 150 leg lifts. Should be pretty quick, maybe 5 minutes. And when we get back, we can look at all the visualizations and just kind of try to make sense of them. So, again, if you guys have any comments, questions, concerns, anything like that, feel free to let me know. I'll go ahead and get started. All right, 5 and 150. 1, 2, 3, 4, 5. All right, so 150 is pretty easy. It's just 3 sets of 50. Let me move the microphone really quick. Sorry if there's any sound on your end. Move this over here. Leg lifts are hard to do in this current position. And good. Okay, so 3 sets of 50. I'm gonna do let's see, what is 3 sets of 50? So what's that gonna be? So that's gonna be, oh, I'm on the little screen down there. So that'll be, I don't know, 10 forward. Wait, how is that going to work? I think 150 is actually a lot now that I think about it. Anyway, so we're going to do, 15, 15, 15. Okay, so we're going to do 20, like forward. So 20 just like regular leg lifts. And then we're going to do 15 on one side, 15 on the other side. So that's what we'll do. And we'll do 3 sets of those and see how this goes. I think 150 actually is a bit high. I think it should have been calibrated to be 90. But whatever, it's fine. Okay. So if anyone's joining at home, feel free to do it as well. If you're not doing it at home, just take a break. Come back in a few minutes. Oh, 1 second. Okay. So I'll go ahead and get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now side to side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 20 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, cool. See, no one said anything in chat. Hope everyone's having a great day. And I'm going to give myself just like 10 seconds of rest. Well, 30 seconds of rest. And then we'll move on to the next set. Another set of 50. Again, it's going to be 20, 15, 15. So, let me get some water. Honestly, this is super helpful. Like doing interval training has like really helped me just like stay motivated and get stuff done. But I think we do calibrate the ones on stream to be a bit high. Again, I think 150 is a bit long. Okay, next set of 50. Let's go. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Side to side. Whew. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 20 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Nice. What do we have here? Gotta go see Amorous. Actually, I think I'm gonna call it there. I'm gonna do 100 today instead of 150, just because I really want to get the fractal stuff done. And yeah, I want to get the fractal stuff done. So I'm gonna move back to the programming stream. So give me just a second to change the position. Okay, should be back on. It looks like everything's done, so we're ready to do the visualization. Let me go over here, change the music back. And yeah, we should be good to go. So I'm actually going to do one other thing while I'm here, and that is to go into exercises. 1 second. Exercises. I think abs. What is this? Core. And I'm going to modify that so it doesn't go up to 150 naturally. Leg lifts. Wait, how did that happen? Leg lifts went... What? Wait, 1 second. How is... I need to look at that really quick. Leg lifts go from 10 to 200. But how is it... Okay, I don't understand what happened there. How it's... It looks to me like difficulty 5 should be about 100, which is right. But we just did 150 of them. Did I do something wrong? The leg lifts goes from 50 to reps 10 is 250. Leg lifts. Was I doing the wrong exercise? Leg lifts 10 to 2. I don't know. I don't know where it's getting that data from. But it looks like it's already fixed here. So we'll just see what happens next time it cycles through. Again, we won't be doing an exercise at 5 o'clock p.m. So let's go ahead and see what the visualizations look like for now. So we're going to run MPV temp video star.mp4. Okay, let's just take a look at all of them. Okay, so I'm just going to watch these as we go along and notate what visualization we're looking at. So this is going to be the visualization that creates the stem, and we're looking at the first operation, which kind of scales along x. So here we see that as we scale along x, we actually start to generate like this weird fractal pattern here. The next one will be a shearing along x. So let's see what that one looks like. Okay, that's kind of what you expect, some sort of shearing along that way, and then a shearing along the other direction. Totally fine. Okay, the next one should be a scaling along y. Oh, no, this is just a linear movement along x. Totally fine. Okay, the next one should be a scaling along y, which just lifts it up. That's kind of what you expect as well. And then we should see a shearing along y after this is done. Okay, I think this is the shearing along y, which is interesting. It looks a lot like the scaling along y, but yeah, okay, interesting. And then it should be movement along y after this is done. Yeah, so now we're moving along y. Perfect. Okay, so the next transformation after this one is going to be the big one, the one that happens 85% of the time. And so this is the visualization we just saw where it kind of goes crazy as it goes this way. And this is scaling along x. So the next one is the one I'm interested in, which should be shearing along x. And we're going to see what that looks like. Oh, that is shearing along x, definitely. Yep, that is what you expect. Okay, then the next one should just be a linear movement. Yep, of each subsequent stem going upwards, which is great. Yeah, that's what we expect as well. Okay, and then the next one should be, yeah, scaling along y. Let's see. Yep. The one after that should be, yep, shearing along y. Don't know why it goes crazy. I don't know where the tree went. It's just gone. Is it going to come back? Are we still playing? Did we lose the tree? 1 second. Yes, we lost the tree at that point. It's gone. Let me just play video. Okay, well, let's just do MPV temp video 15.mp4. Yeah, there's nothing in there. Oops. Yeah, no, I think I know what happened. Let me go up here. I think I know exactly what happened. At the end of each game, yeah, so there was a divide by zero error somehow. I'm not exactly sure how. But what I should be doing is, in each of these guys, I should be reinitializing the point to be 0, 0 in here. So let's go ahead and just define the point to be within that loop. dd here, paste in here. Now, did I time this? I don't remember. Okay, so let's go ahead and run that. And let's just run G++. And let's see, what was the last time I ran this? I did not. So let me time it this time. And and we'll run it again. I mean, we know it takes less than 10 minutes, right? Because we only ran it for less than 10 minutes. So we have plenty of time to talk about life, liberty, the pursuit of open source software, anything you guys feel is like relevant to talk about. Yeah. I always tend to like want to talk about stream stuff. Like for example, like, you know, doing the workout every hour on the hour, I do 100% realize that like probably a lot of people don't like that section of the stream. Like fairly confident that people generally don't like that section. But at the same time, like you can tell from the viewership and stuff like that, but at the same time, it kind of allows me to stream for a lot longer. Like you can tell after I do the workout session that I'm just like way more motivated to do the stream. Like I'm more excited. I'm able to speak more clearly and everything like that. So I kind of feel like it's a necessary evil. I mean, I don't see it as an evil, but it's a necessary part of the stream in my opinion, to keep the stream for going longer than 2 hours. Plus, again, it allows us to do something slightly different. We're usually like doing incredibly technical content, so allowing us to do something that's, you know, maybe a little bit less technical, I think is really, really worthwhile. It's completely fine. You do you. Hey, Trash Talk. I know I said hey earlier, but yeah, that's fair. I don't know. I am going to be trying to do like, you know, longer streams and stuff like that, and I have been trying to do it. I've been saying that all year, but it's just hard to do this year. It's been a rough year in terms of just moving and all this kind of stuff. 2020 was a rough year as well, man. It's just been a rough couple of years, and not just because of COVID, because of a bunch of other things. Like 2020 was going to be a rough year, even if COVID didn't happen. But with COVID, it just put everything over the edge. I'm thinking, so I might do a stream tomorrow morning, which is a time zone I don't normally stream on. To do a 3 Blue 1 Brown comic book. Hear me out. My work for Grant right now is basically translating all of his videos into some sort of text form. And I was kind of realizing that maybe it makes sense to like when we have areas of like very high image density, which his visualizations tend to have. I don't know. I kind of feel like it might be worth like maybe transitioning to like a comic E style. Have you seen the SN15 landing? I have not. I don't even know what SN15 is, if I'm being honest. SN15 landing. Yeah. No, I haven't. I kind of don't want to watch it though. I'm sorry about that. What is this? Oh, this is some random site that we found. Let's go to clear up the browser a bit. It didn't blow up this time. Cool. Yeah, I don't know. I feel like a very specific interest. It's kind of weird. But yeah, I'm happy to see the progress with this type of stuff, you know? Okay, so what are we on? We are on video11.mp4. So we're about a quarter of the way done with the visualizations. And then we'll take a look at it one more time when that is done. Yeah, we're going to have to look at it kind of like we did last time, where we just kind of look at them all at the same time. But we can skip through the animations that we've already seen. The question is whether these visualizations are actually going to be useful for people in their understanding of what the Barnsley Fern does. I kind of feel like they will be. Yeah, I kind of feel like they will be. But also, we're not really answering the fundamental question, which is, let me just go here, CD project, Simuleos, Fractal, MPV, oh, what are they called? Barnsley 0 through MP4. Okay, so MPV, Barnsley 0, well, Barnsley, let's just do star.mp4. Okay, so essentially what we have here, I'll go ahead and answer your question, Kronborg. So essentially what we're looking at here is 4 different transformations. One that basically brings all the points into a stem location. Another that will essentially bring whatever like objects that we have in space and move them kind of up and a little bit to the right. We have another function that will allow us to kind of rotate a little bit, and a final function that will allow us to flip along the kind of x equals negative y, or x equals y axis. And when we put all of those guys together, we end up creating a rather interesting fractal. So Barnsley.mp4, the Barnsley Fern fractal, right? Now, what I'm trying to do is find a way to represent the creation of this fractal that helps people understand how those 4 functions will create this fractal in the end. Because it isn't really clear how that exactly works. Like, how does it create the fern pattern, right? And so to do that, what I'm doing is I'm taking each function that we can multiply, that we can work with, and I'm kind of just like modifying the elements of this function to try to get a better representation, like try to explain what each function is doing. And so these visualizations are computing now, and hopefully we'll be able to look at them in just a second. How do I run the simulation? I don't see fractal makefile in the directory. It says at the top, sorry, it's right here. So it's just G++ and then your path to the GathVL directory. Sorry, I didn't create a make file because I have a lot of different C++ files that all do different things. So I said, screw it. It's a standalone file, so it's not too hard. But the thing is, you do have to build the GathVL directory, which is kind of annoying. So just do make lib. If you type make lib in the GathVL directory and then you do this will work. So you have to make sure you get the GathVL directory as well. I have not committed what I put up right now. Again, it is a standalone file, so think of it more of a script than as a as a software package. So let me get some water. That's interesting. Yeah, so this is what we're trying to do today. So I think tomorrow we're going to try to find a different visual and see where we can go. Hey, Radu, how are you? Now, again, I'm letting you guys know I have less than an hour left in stream. I got to stop at like 5:15 today, so in like 55 minutes or something like that. Just because, again, we have people coming over at 5:30 to look at the apartment to see if they want to, rent it or not. It's kind of a pain. But it is what it is. I'm streaming when I can every day for the week, which is basically 2 hours a day whenever I can find the time. But probably Saturday will be a longer stream again. I do actually really like the feel of doing like these longer, like 6 to 7 hour streams. I'm actually going to be moving a few times. I'm going to be moving from Boston to Alabama in May, and then I'm going to be flying from Alabama to Okinawa in June, and then I'm going to be flying from Okinawa to Barcelona in September. So there will be a few days where I can't stream at the end of May. There will be basically 2 weeks when I'm in quarantine in Tokyo where I probably can't stream in June, and then there will be 2 weeks where I probably can't stream when I'm in quarantine in Barcelona in September. So again, I'm just letting everyone know this well in advance, so there's no questions as to what's happening. Also, this is why I'm not necessarily encouraging people to subscribe right now, because I know in a month I'm going to have to take 2 weeks off, so your subscription will only last, well, right now it would last a full month, but after today, it won't last the full month, right? It will only last 2 weeks. Well, it won't last the full month. It will be off by a few days because I know I have to take time off in the next few weeks, so... But I do genuinely want to start streaming more frequently and stuff like that. It's just, my time zones are going to be crazy again. It's going to be weird. What are we on? We're in video 3.1, so we have 5 more videos to make. We are getting there one step at a time. So then we can take a look at what each of these transforms are doing in a second. Interesting. I mean, Okinawa will be interesting. Yeah, so I used to live in, I don't know if people know this or not, but I mean, I think most people do. I got my PhD from the Okinawa Institute of Science and Technology. You were there. This isn't new information. I lived in Okinawa for 5 years, right? So it's totally. I really do miss Okinawa. It's my favorite place I've ever lived. And don't get me wrong, Boston is nice, but it's just not. I don't know. It's not Okinawa. Okinawa feels like home to me. Alabama doesn't feel like home, and I think that's because even though I lived in Alabama for longer, and that's where my family lives, I was not there during my adult life, right? I was there, I was there for my undergraduate, but the years that really shaped who I am right now were the past 5 years, right? The way I see it is you as a person change dramatically every year, right? Well, maybe not super dramatically, but you as a person are really mostly defined by what you've done in the past 5 years, not what you've done in the past 50 years, So if you're 30 years old, yeah, you've had 30 years of development up until your current age. But the past 5 or 10 years are probably the ones that define who you are the most, right? And so for me, those past 5 years were spent in Okinawa, right? And so I kind of see that as my home more than I see anywhere else. Plus, this past year since I moved to the U.S. it's just been a mess, honestly. Did you have to do your PhD in Japanese? No, it's a purely English speaking institution. So everything was done in English. It's actually super interdisciplinary, and there were people from all over. So, for example, my lab had... let's see, how many people? It had 20, 30 people in it, and there were 16, 20 countries represented. So there weren't very many countries that were repeated. A lot of people came from different places. And I think that was really special about the Okinawa Institute of Science and Technology. Okay, it took about 10 minutes, which is about right. So now I'm going to run MPV temp video.mp4, video star.mp4, and we're just going to watch it again. Okay. So I'm just going to go through them all again, and we're just going to look and see what they're doing. You're from Alabama, didn't know or remember it. I don't know or remember half the time. Okay, so here what we're doing is we are modifying the stem function, the one that creates the stem in here, and we're first starting with the scaling along x. And what you notice here is that we actually start to create a like little mini fern down here at the base of each of these stems, which is interesting to some extent. It's just kind of, again, scaling everything out by x. Canadians, I don't know so much about Canadians. This is shearing along x, which I guess is kind of what you expect. It's weird that, yeah, it's a bit weird, but it's kind of okay. The next is just movement in x. Again, it's just moving where that line is. It's not particularly fascinating. The next one should be scaling along y, which I think will change the length of it. Yep. And then there will be shearing along y. Shearing along y is a weird one to me for this one, because I don't know. It looks the same as scaling along y. Like all of these next three looks the same. Yeah, they look the same, and I don't exactly understand why. Let me get some water. The stream is pixelated. Oh, that is probably because the bitrate. Let me increase the bitrate really quick. 1 second. So file, settings, output. Let me increase the bitrate to 3500 for a second. Apply. Okay. Do I have quality options? I do not have quality options today, which explains why I have a low view count. Okay, then I'm gonna keep it low. Unfortunately, you guys might just have to deal with the pixelation, and I'll see how bad it is after stream is done. I'm sorry. 2. Okay. Yeah, I don't have quality options today, so there's not really anything I can do. 1 second. Yeah, well, that sucks. Well, it is what it is. Yeah, so I'll just keep playing it. Maybe you're rendering that full screen. Yeah, it's actually not full screen, just for the record. Okay, so the next one's going to be a scaling along x. This is the transform that you saw in the upper left-hand corner. It's, kind of what you expect. Yeah. Okay, this is a shearing along x, which is, I don't know, it's interesting. So the next should just be a movement along x. And the interesting thing here is you can actually see the differentiation. Like, you can see what this function is doing. It is literally just shifting and bringing you up towards the left or right, right? And you can see that because it's splitting each of the sections of the Barnsley fern around, which is cool. Like, you're seeing what it is. Okay, so here is then a scaling along y. The next should be a shearing along y after this is done. Still scaling along y for now. So this should be a shearing along y, which I think is going to break, actually. Oh, no, it didn't break this time. Perfect. Okay, good. Oh, that's kind of cool. I like that one. And then we should just have a movement along y, which is doing a scaling for some reason. And I don't understand that. Which video is this? This is 1.5. Okay. I don't know why this is doing a scaling exactly, but that's interesting. Okay, so here's the one I was interested in. So this transform is only modifying the left part of the tree, which is interesting. So that means that this one must be somehow determining the left leaves, which is cool. Good, that's exactly what I wanted to see. That's why I wanted to do this transform. Perfect. This is exactly showing me what I wanted to see. So then the next set of transforms should specifically be modifying the other set of leaves. Okay, this is again movement along x, so we should see the other, like, movement along y and all this kind of stuff in a second. Let's see. I think you got what's going on from the start. I think I know what's going on. The compression algorithm, because the motion is changing so many pixels on frame, it requires more bit rate. Right. So that's why I wanted to increase the bit rate, but I can't increase the bit rate because, unfortunately, I don't have quality options today, so I can't do anything with that. So I'm sorry about that. That also explains why my viewership is like really low. Anyway, so here we have scaling along y. I think this is scaling along y. Yeah. And then we should have shearing along y. Yep. Great. And then we should have, what's the next one? It should just be movement along y. Yeah, it's just moving it up. Perfect. So the next one should be modifying the leaves on the right. Yeah, should be modifying the leaves on the right. Let's see, just to see if that's exactly what's happening. Yep, just modifying those leaves. So this is scaling along x. Next we should see shearing along x. I'm going to check my stream really quick. It looks fine. It looks fine. I mean, it's not great, but it looks as good as you could expect. Okay. So that seems fine. What's the next one? So the next one should just be movement along X. Perfect. Yep. And then we have, should be scaling along Y. Yep. Okay. Yes. Right. And then the next one should be, okay. Yep. And then we have one more, which should just be moving along Y, which I think should just move them upwards. This is a good set of visualizations. I quite like this, actually. I like it a lot, I think. Look at your face. Is there something wrong with my... Well, okay, my face might be... Yeah, okay, my face is super pixely. Sorry about that. But the visuals look fine. Yeah. Sorry. Again, it's probably actually pretty bad. Even with this visual up here, it's probably pretty bad. Yeah, it's not great. I'm probably doing these iterative function system visualizations are not the best, but oh well. We'll see. Okay. But yeah, just the only way to do better is to increase the bit rate. So, and there isn't, I can't increase the bit rate right now. So, yeah, it's always super unfortunate that this is actually one of the reasons why I was considering streaming on YouTube instead of Twitch, because YouTube just has better algorithms and does better, and they allow you to run on lower. You can run with a higher bit rate, and then it will, you always get quality options, right? And so you don't really have the situation where, some days you just can't stream, or your stream is going to be majorly, some people just can't watch your stream today, and that's just today, because I don't have quality options, and there's nothing I can do about it, It's super frustrating. The only reason I became a Twitch affiliate is because you get, a slightly modified chance to get, your chances of getting quality options is slightly higher. And that's the only advantage. And it just kind of sucks that the reason people become affiliates, the reason people become partners is only for technical reasons. It's just kind of a really weird, I don't know. I don't like it that much. Okay, this is actually exactly what I want to see with these visualizations. So I'm super happy with that. Because it kind of showed one transform creates a stem. The next one creates successively bigger leaves as you go higher up. The next one will create the leaf pattern on the left, and the last one will create the leaf pattern on the right. And the reason I needed this was because, oh yeah, you can. I see what you're saying now. Yeah, I see exactly what you're saying now. The bit rate's actually quite bad. Oh well, nothing I can do about it. Okay, so what I was going to say was the following. Okay, if we read the visualization in here. This does not make sense. It's trying to explain exactly what's happening, and it's doing it in such a weird way. It's oh, this little red triangle in here is going to be moved over to this leaf over here. It's but that's not what's happening, That's not what's happening at all. What we're seeing is literally this entire fractal, all the points that are being generated, turning into this leaf over here on the left, right? And so we have four functions. One that brings you successively upwards, one that rotates you to the right, and another that flips you over to the left. Rotates you to the left, and the other that flips you over to the right. That's all you have. So now, I think it makes a lot of sense. 1 second. I'm trying to think of any other visualizations that we could use here. And there is one more that I'm thinking about making, which will... essentially do the iterative function system, but ignore one of the functions, right? So it will ignore a function that brings you upwards or something like that. But I think actually this is all I need to show. I think now with those visuals, we're good to go. Okay, so now we have to think about how we're going to go from here. So what I want to do next is I actually want to create a visualization of this with a white background. Yeah, with a white background. And the reason I want to do that is because I want to do it. I just want to try it because I probably want the white background one for the algorithm archive. And that way I can do a visual with a black background for YouTube and a white background for the algorithm archive, which is what I typically do. And I think this is a good explanation of how these affine transformations modify the fractal and stuff like that. You need to darken the green, I think. Yeah, so that's what I want to try. So let me just see what happens if I just do this really quick. So I'm going to comment all this out. Yep. there, and let's just modify the background. Right, I forgot how to do that. So vi packet directory computus, and let's see, let's go into Gauss visualization. G down here, what did I do? I did, I think I can just do that. Roll that background color here, and let's just see what it looks like. Perfect. And we're gonna do Barnsley. Okay. Quit here, and now we're just gonna run g++ / Barnsley, and let's just see what happens. Give it a second, and we're gonna see what it looks like. For those of you guys who may or may not be averse to white images. Oh, by the way, I just realized I screwed up. This isn't actually doing anything because I forgot to add the encoder, include the frames afterwards. Try it again. G++. That's such Barnsley. Okay, give it a second, and we should get a video. So I'm gonna let you guys know it will be a white image. I just made a white image. Okay, so if you guys need, please put your sunglasses on, because if you guys are averse to having white backgrounds, I do realize a lot of you guys are like that. You might wanna put them on, because this video will be different than the other visualizations that you see on screen. So MPV temp video.mp4. Okay, I can't see anything, but I think that's fine. Looks fine to me. Let's increase the number of points for Barnsley. I think the green is actually okay. So let's increase the number of points by a factor of 10 over here and run it one more time. G++ / Barnsley. And we'll see what happens. Fear of code, hey, how are you? Okay. So, yeah. And I think honestly, maybe this is where maybe we call it for now at this stage. Once we have the white background working, then I just need to kind of burst through, get all the animations. We might just spend a day just like getting all the animations. Like that might be what we do tomorrow. But we need to think about like the best way to like represent some of this, like, is there a better way to show this data? How do you get your terminal not have any anti-aliasing using that font? Extern modern variant. I'm sorry, what do you mean? What is anti-aliasing? I'm so sorry. I'm using Xterm, if that matters. I'm using a bitmap font. I'm not using a vector graphics font. So that's actually why I'm using Xterm, because I don't like the so I'm using a bitmap font. So I'm not using a like the vector graphics. Most terminals won't use bit. Right. So that's why specifically I'm using Xterm, like because I don't like the other types of fonts. So let's go and do MPV temp video.mp4. It's white background, but I think it looks pretty good, honestly. I mean, I'm waiting for the green to appear. Oh, okay, so we didn't get enough green there. I guess we need to, let's go, okay, Barnsley. Okay, what do we have? There should just be a function that is for Barnsley. Let's get that visual done. Barnsley here. Okay, so what are we doing here? We are doing, we're creating the points bin size. Wait, 1 second. I think I just need to increase the bin size. Yeah, let's increase the bin size. G here. And so we're going to increase the bin size to be 10 times that size. Like that. Go over here. Now we're on G++ ./Barnsley. So the bin size is the number of points that we're drawing at each iteration. So we're going to give that a second. And then hopefully this will look pretty good. I think it will, honestly. But another advantage of Xterm is that you can actually use Sixel graphics, which are a way to like show GIFs and animations and stuff in your terminal, which is really cool in my opinion. And I just wish more like terminal emulators actually supported that, Okay, give it a second to do the render. It does take just a second, and then we should be good to go. 1 second, let me check. Yeah. Yep. Okay, give me just a second. Well, what kind of graphics did you call them? Sixel? Yeah, here, let me show you. CD images, pictures, LS here. I don't know what any of these Sixel to PNG Giphy .gif. Oh, did I pull up the wrong one? CD images, pictures. That was here. I don't remember what any of these are. So let me just do, I think Giphy.gif is the one. So Sixel to PNG Giphy.gif. Ah, that still didn't work. Let's just Sixel. Pretty sure I installed libsixel. This guy. I just forgot the commands for it. I'm so sorry. Image to Sixel. That's what I'm looking for. Image to Sixel. And then I think if I do Giphy.gif. Yeah, there you go. Okay, so this particular GIF isn't particularly good, but let's do another one. Clear. Move this over here, and let's just grab the one that they have here. So what is that one? Google. So we can do image to Sixel, HTTP, goo.gl, 3v ROOV, and that should work fine. Oh, what? Well, let's wget that image, and hopefully that'll work, unless I'm doing something really stupid. There. Oh, it doesn't exist anymore. Oh, that sucks. I used to have it on my old computer before I set it on fire. Crap. Okay, let's just get a random GIF then. I mean, anyway, the point is you can show the images here. Do I have backgrounds maybe? CD backgrounds, ls here. So I can do image to Sixel, arch.jpg, date.jpg, L6. So anyway, here I just did L6 on this guy, and if I run it one more time, maybe if I make it huge, make the images bigger. No. Anyway, the point is you can show images in your terminal. It's kind of cool. It's called libsixel. It's nice. Okay. So I used to have better visualizations. I don't have them on hand right now. So mpv temp video.mp4. Okay, this looks fine. I'm questioning what's happening up here, why there are all these dots there. But overall, I think that looks okay. I think the green is fine on the white. Yeah, I think it's fine. Yeah. Yeah, I think it's okay. Cool. Okay, so I now know we have a lot of visuals that we have to make, which is cool. So now it's just a matter of making all those visuals and, yeah, trying to make sure that they're high quality enough. So we're going to have to generate a lot of points for this. So I want to generate probably 100 times as many points. So I'm just going to let it render all night is what I'm going to do. And this will hopefully give us a set of visuals that will work for what we need them for. And then we can go from there. So I think this is a good stopping place for today. We got the visuals that I was hoping to get done. It gives us a better understanding of what each transform is actually doing. And now we have, I think we have all the visuals that we need for the upcoming video, I think. So that's it for now. Let's go ahead and close stream then. And I will see you guys tomorrow. I don't know exactly when I can stream tomorrow. I know I can stream at 4. I can probably stream from 4 to 8 tomorrow. So I can probably do a 4-hour stream then. I can also probably stream tomorrow morning. I'm going to see. But if I stream tomorrow morning, it'll be on something different. It'll be like a 3 Blue 1 Brown. I guess I'll call it a 3 Blue 1 Brown comic book or something like that. Anyway, guys, thank you so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I'll see you guys around next time for the next episode of Simuleos, where hopefully we can kind of get everything that we need for the Barnsley Fern visualizations ready to go. There's one visual that I'm still hoping to try to figure out. But we're getting there, and I think tomorrow we'll do the last visual that we need. Yeah, I think tomorrow we'll do the last visual that we need. Yeah, I know exactly. Actually, let me go ahead and write down the one that I want. So I want to, I'm just going to put a big to-do in here. To-do. And I'm going to say we want visual of all Barnsley, of pre-generated Barnsley Fern doing each affine or each transform. So that's what I want to do tomorrow. It shouldn't take too long, and then we can just kind of get the final visualizations good to go. Maybe work on the algorithm archive chapter, and I think we can just get a video out this weekend. It's a relatively simple topic, one that I feel like a lot of people have done, but maybe not in the exact way that I was hoping for it to be done. And we've been sitting on this for years, so I figured let's just do it. We have a lot of cool visuals, so at the very least, people watch it because it looks pretty, which is, I think, cool enough. Blurgle Crunchin, thank you so much for following. Really appreciate it. And that's it for now, for real. Talk to you guys tomorrow. Thanks again for watching. See you next time. Bye, guys.